All right, we should be good to go. Just gotta sync up the TikTok chat with the rest of the chat. Should be good. Welcome, everybody. I hope everybody's having a good day. Good morning or afternoon, wherever you might be. We want you. We want you. We want you. That song's stuck in my head. I am sleepy. I am sleepy, oh so sleepy. Oh so sleepy and eepy and stray. So here we are. So you guys know the drill. Today is Ask a Physicist, so we're going to be live for hopefully 3 hours. The plan is to do the first hour and a half of answering every question available. And then in the second hour and a half, I'm going to close the chats. Anybody can still watch, but I'm going to close the chats to just paying members. Everybody can still watch the questions, and I'm also going to open up the guest box so that people can come in and ask questions in a more direct way rather than just typing. So that is that's the plan for now. If you haven't already, and you want to learn about something a little bit sad that happened, a very important physicist died on Friday. His name was Francois Englert. He together with his mentor were the first people to ever explain how particles get mass. This was before Peter Higgs. They published their work before Peter Higgs did, about a month before. And Englert and Higgs shared a Nobel Prize in 2013. Englert died last week. So a little on the tragic side, but it's a good, but you know, he lived a long life, he achieved a lot, and he'll be remembered forever. So make sure to go watch that video I made about his work. I go into the detail of exactly how he came to that conclusion, how he and his mentor Robert Brout came to that conclusion, and come back and ask some questions. So let's answer some questions. What's your opinion on the UFO and UAP photos released by the USA government? Look, those photos and the testimony, these are all sufficiently vague that basically I'm of the opinion, show me a body, show me a craft, or I'm not going to be convinced. Like, you got to do more than just, like, you know, grainy footage and testimony of people who heard a thing from a person who heard a thing from a person, etc. Opinion on DRGT model and its future? I've never heard of it. Are we atoms right now? We are atoms right now. Bit personal, but are you single? I'm not. How can I be like me? Be like you? Well, the first thing to do is to get a bunch of degrees. The second thing to do is to become like compulsive about posting on social media. The third thing to do is to move to Europe to do research. Those are the 3 steps. Which math influences your field the most? Well, for me, it would be differential geometry. But differential geometry are, you know, differential geometry and general relativity go hand in hand. They were developed almost simultaneously, like within 20 years of each other. Wait, is this live? Yeah, of course it's live. Would you be willing to peer review a white paper I wrote on mathematics fractals? Nope, not really a thing I do unless a journal asks me to. Or, you know, a colleague. Do you have any advice for someone going into the STEM field? There is no the STEM field. There is STEM, which is like, you know, dozens of different fields on their own. But they're all going to have something in common, namely you're going to have to do math in all of them, so make sure that you're fluent mathematically. That's going to be the biggest stumbling block for most people who end up going into STEM, at least in my experience. No Star Trek needed? Well, I mean, the Star Trek couldn't hurt. Do you believe in the multiverse, and how is it different from many worlds? So there are a few different ideas of a multiverse. So there's kind of like the cosmological multiverse, where they're just spatially separated pockets of universe, pockets of matter. This I think is plausible. I think it's you know, I'm not like, I don't see any evidence for it, but it's at least like seems reasonable. You know, but I'm agnostic about that. The many worlds is not that they're like distinct, separate, spatially separated universes, but rather that there is one universal wave function, and that universal wave function describes a whole bunch of different kind of coexisting universes that can't talk to each other. And then there's the stringy landscape, which is sort of like another kind of cosmological multiverse, but it's not necessarily spatially separated. Why are you so, as a matter of fact? I don't know. What's my research on? I do research in mathematics and on conformal geometry, and I do research in early universe cosmology and some black hole stuff. We have a super chat. Super chats, remember, super chats always get first dibs. From the Knights Who Say Knee with the $5. As a physicist, I know you'll be happy to learn God exists because the moon is tidally locked to Earth. Trust me, bro, I heard it on DZ, Rock Hard for Doug. Or Rock Hard for Blitz, rather. Well, you know what? I do appreciate the comment. It must be true that God exists because the moon is tidally locked to Earth. Good point. I'm going to jump down to the bottom. Sorry, somebody asked a question I wanted to. Yeah, jump down to the bottom so I don't miss anything. Sorry for being a little bit behind. DRGT is Derum Gabadadze Tali model for massive gravity. I haven't heard about this. There's so many new models that come out every single day. I can't read all of them. I'm starting my bachelor's in photonics in a few months. Do you have any tips or advice for me? Again, and this is the advice I give to everybody, make sure that your math is strong. Photonics, especially if you're doing like any sort of theoretical work, photonics is going to be very, very heavily math-based, so. Could an advanced species in the Boat's void be able to know they're in a cosmic void? Yeah, sure. What symmetries are globally unbroken? Charge conservation, seems to be. Any sort of charge conservation seems to be globally unbroken. Hey man, I'm in second year college now. What's the hardest topic when you were in an undergrad? So the hardest topic, so the class that I did worst in, the thing that was hardest for me was I took a topology class as a freshman, and that was a mistake because I just wasn't mathematically mature enough. Thinking back, I probably would do fine in it if I had taken it in second or third year. Taking it as a freshman was probably a mistake. Statistical mechanics was also hard, but I think that's because I didn't have a great professor, and I just think that statistical mechanics is hard to teach, not that the topic is particularly challenging. I have to jump down to the bottom because you guys are asking a lot of great questions. Thank you so much. If I travel back in time for my present, is something changes in my present? Well, I don't think you can travel back in time. If Isaac Newton was present, what unfinished questions of physics would you ask of him? Oh, well, I would honestly, he would probably have to ask me more questions than I would ask him. Once he was all caught up, I would ask, I don't even know if he would be influential as far as physics is concerned in the modern language. Like, I just don't know. His philosophy may have gotten in the way. Is this Twitch? Well, it is live on Twitch. It's also live on 2 YouTube channels and on TikTok. How do I get started in a career in physics as a US veteran and current physics major? Entry level? There is no entry level physics. What you do is you get a physics major, a physics degree, and then you go to grad school and you get a PhD in physics. And then you hope that you get a job at a national laboratory or at a university or at one of the very, very few private companies that actually do physics research, like genuine physics research. How can I get into physics? I love it, but I don't have a huge understanding. Well, it depends on how deep you want to go. If you just want to go pop sci level, the deepest you'll probably need to go is to read Sean Carroll's books, or maybe Leonard Susskind. Is it Leonard Susskind who wrote The Theoretical Minimum? Yeah, Leonard Susskind's book, The Theoretical Minimum. So there are two books, there's The Theoretical Minimum by Leonard Susskind, and then there's The Biggest Ideas in the Universe by Sean Carroll. If you can understand both of those books, then you are going to know as much or more of physics at the lay level than basically anybody else. If you want to actually start learning physics, like in the sense where you actually learn and understand like the underlying stuff, you pick up a college textbook. There's a book by Friedman or Young and Friedman called University Physics. There's an online version or an online university textbook called University Physics, hosted by Rice University on OpenStax. Pick up a textbook and start reading, start working through it. Did you just take point set topology or algebraic? It was point set topology, but I was like 18. I was not ready. What is mathematical maturity? It's hard to put a word, it's hard to really explain what's going on here, but there's a level of like being able to, there's a transition period, right? From when you're in high school, the math that you do is almost strictly computation. And in the last 2 years of an undergraduate mathematics degree, you don't do computation anymore, you do proofs. And there's a transition that happens between doing computation and doing proofs. And that transition is, that is the first step in becoming mathematically mature. And I just wasn't there yet, is the reality. I wasn't, like, the course I was taking was a proof-based class. It had no prereqs, but it was a proof-based class. And so it kind of requires that you've already made that transition. Have you ever participated in IFO as a high schooler? No. Do you think that hard labor jobs should pay at least as engineers? I guess it depends on the job, right? So where do you work besides YouTube? Also TikTok. So think of what a professor does. A professor spends 40-ish% of their time teaching and doing administrative stuff, and 60-ish% of their time doing research, maybe 50-50. So I spend about 50% of my time doing science communication. I make videos on TikTok and on YouTube, and I do science communication there. And then I also, and part of that 50% of the time is also streaming. And then I spend 50% of my time doing research. You must be a shit psychiatrist, because if you were good, you would be working instead of live on YouTube talking about some nonsense. Well, I'm not a psychiatrist, I'm a physicist. But I take it that your view is kind of sensible, given that you can't read. From Mr. Delightful Song with the 2,500 Chilean pesos, if movement is relative, what is the difference between a moon orbiting a planet and a static moon and a planet rotating with the sum of the two vectors? So I don't know what the second one is getting at, a static moon and planet rotating with the sum of the two vectors. I mean, you can put your frame of reference wherever you want. You could put your frame of reference on the moon and then have the planet moving around it, or you could put your frame of reference on the planet and have the moon going around it. Either one is equally valid. It's just the equations of motion get more complicated when you are in kind of the less natural frame. From Artorius with the $2, what's your favorite dinosaur? The Gallimimus. Sorry, it's just the reality. The Gallimimus is he's just a little guy. Oh my god, what research do you do? I would like to read it. Well, you can go to my website. It's blitz.phd. There's no .com, it's just blitz.phd. There's a tab there that has all of my research papers. They're all freely accessible. It tells you, of the ones that have been accepted into journals, it tells you which journals they've been accepted into. I think like my 3 most recent papers haven't been accepted yet because they're still in the peer review process. But yeah, just go to blitz.phd. In fact, I might even just pull it up for you guys so you guys can see what it looks like. Very proud of this website, even though, you know, I was a supervisor for its design. I didn't actually design it, Claude did. But so you can just go to the research tab. It has a nice description. I think it's a nice description. And then just links to all of my papers. You can just click on them and it'll take you to them. Just go to view PDF and you can find the paper. So yeah, that's the website. Check it out if you want to see my research, if you want to see the kinds of things that I do. From Get Stanfield with $5, very much appreciated. Hey, Dr. Blitz, is there any update on the reconciliation of quantum mechanics and gravity yet? Can you explain your answer for a layman? Okay, so I get that people ask this question because they want to hear about it. If there was, you would have already heard about it. You wouldn't have had to ask me. There are questions that are unanswered that are big enough questions that they will make headlines, like headlines of the New York Times when they're resolved. You don't have to ask me, and this is no shame at you, Get Stanfield. You're very generous, and I appreciate you. But lots of people ask questions like, "Oh, any update on dark energy? Oh, any update on dark matter? Has anyone solved dark matter? Has anyone reconciled gravity and quantum mechanics?" Like, when that happens, you will find out from the news, not from me. How long does it take on average for you to write a paper from the idea to publishing? It really depends on the paper. There was a paper that I wrote, there was a paper that like I had the current, or I wanted to write for like 3 years. And then over the course of about, there was this thing that I thought was true and I wanted to prove it was true, but I didn't know how for like 3 years. And I wasn't really like actively working on it. It was kind of just rattling around in the noggin. Then I went to a conference, and over the course of the next 2 weeks, because I was inspired by the conference basically, over the course of the next 2 weeks, I started writing and finished and submitted for publication. And this was like a 2-week period of just working on this problem. That happens sometimes. There was also a paper that I worked on for like a year and a half, or maybe even 2 years, and that was because my collaborators, both of them had children in the interim, and we all had other things going on, and the idea was kind of messy. So it really just depends. From Sheriff Slug with the $10, do most physicists think that time is infinite, or that the Big Bang was the beginning of the universe? Also, could you put me some literature papers to look at? So as far as I don't know the personal position of most physicists. As far as I know, this hasn't been surveyed, but my understanding is that if you ask physicists what the deal is with the Big Bang, most of them will say the Big Bang says nothing about whether the universe had a beginning or not. So it kind of sounds like agnosticism, at least regarding the Big Bang. And from Mr. Delightful Song again, thank you so much for the 2,500 Chilean pesos. I mean, if the moon stops but the planet rotates to counteract it for it to seem like it's moving before, doesn't the moon fall into the planet? Well, no. So from the moon's perspective, the equations of motion are different, so that the planet won't fall into it. Blitz, what are Wilmore invariants? So it is a conformal invariant, meaning that it is a geometric quantity that only depends on angles rather than scales, and it characterizes shapes that are put into higher dimensional spaces, and in some sense it captures like how rigid the shape is, how resistant it is to bending. From Phoenix 801 with the $10. By the way, Sunshine Nate, thank you for the lots of gems. From Phoenix with the $10, I'm an agnostic atheist, and I'm curious what you think of the fine-tuning argument, where they argue that forces like gravity, strong nuclear, etc. are tuned so precisely. So my view is that we just don't have enough physics to be able to establish whether there is fine-tuning. I mean, no physicist alive is going to say that we have the final version of physics, that we're done with physics, that that the constants that we have now are the final constants, that the forces that we have now are the final forces. So I just don't think that we're at the point where we can say whether things are finely tuned yet. And from Jack Fetter with the $5, actually being a psychologist might be better for flirt interactions. Oh, that's a fair point. That's a fair point. I appreciate it, Jack. How do you see light rings around black holes if it can't escape? So the light rings that you're seeing around black holes are not light beams that have fallen into the event horizon. These are light beams that are just skimming past the event horizon, basically, or about 50% further out than the event horizon. And so light can orbit a black hole. Like, that's a thing that can happen because the gravity is strong enough to pull it into a circle without pulling it in. Have you ever wrote a preprint that had several issues you didn't realize until later? Yeah. How do you get your ideas for your research? Do you just get a flash of something seeming wrong? It just depends. So sometimes there's kind of like a natural follow-up from previous work. So if I have a paper on this that only works in even dimensions, then I might think about, okay, well, what can I say about this same phenomenon but in odd dimensions? Can I prove that it doesn't work? Can I prove that it does work? You just have to change something. As far as physics is concerned, it's more of like there's kind of two routes that I can take. One of them is that I see something in mathematics that makes me think, okay, well, this idea in mathematics is a neat idea. What if I apply it to physics? What if I apply it to black holes? Or what if I apply it to the beginning of the universe? So that's one way. Another way is that like I'm kind of just toying around with ideas, or I'm like reading a book, or I'm reading an article, and either something seems wrong, and so I'm like, oh, maybe I can fix that, or it just inspires me to be like, well, what if I combine that idea with this idea? Or what if this, sometimes it's just like a flash of inspiration, but the flash of inspiration has happened like exactly 3 times. So it's not common. But if light orbits a black hole, then how does it reach us for us to see it? So it's not always a perfect orbit. So what can happen is that there is an exact distance away from a black hole that light can enter an orbit. But if you're not that exact distance away, then what it can do is it can swing around 5 or 6 or 7 or 8 times and then shoot back to us. But what you're seeing in the background that I have here, if you're watching on the horizontal, if you're seeing that, then these light rings are really just stuff that's falling into the black hole, getting really hot and glowing, and then emitting light in all directions. And some of that light gets back to us. What is conformal geometry? Conformal geometry is it's the geometry of angle without size. Do photons experience time if they travel at light speed, or is the world around them frozen? Photons don't experience anything. There is no sense in which photons have an inertial reference frame from which we could say they experience X. The point is that when we talk about XYZ thing experiences less time when we say something is traveling close to the speed of light, that's true because there is an inertial reference frame that exists for something traveling at 99% the speed of light. There is no such reference frame for a photon traveling at the speed of light. Guess what physicists are good for? I don't know, like inventing the internet. How about that? Or rather inventing the World Wide Web, inventing lasers, inventing MRI machines. From Sheriff Slug with the $5, thank you so much, by the way. Why do some websites like NASA or other scientific websites say that the Big Bang was the beginning of the universe if most physicists disagree? Because those websites are not talking or engaging with the scientific community like in a updated way. And their goal is not to be precise. Their goal is to just convey an idea, which is, vaguely right. From Enough Data with the $5, you were in my dream last night and I was asking you about the stress energy tensor. I see you're using your magic cauldron to infiltrate dreams now. Ah, yes, this is a thing I do. I sometimes infiltrate dreams. And from Git Stanfield with the $5 again, do you have a favorite physicist? Also, do you utilize any general or special relativity in your personal work? So yes and yes. Favorite living physicist is probably Roger Penrose. Despite him being a little bit annoyed that I asked for a selfie, he is probably the physicist that I look up to most who's alive. Albert Einstein, if we include dead ones. And yes, general relativity, special relativity I don't really use because it's subsumed by general relativity, but general relativity is like the core of the work that I do. Is interdimensional just time travel in a sense, or is a dimensional being literally exists? So none of this is physics, this is science fiction. What's your take on that there's only one single electron ever? It was an interesting idea in like the 50s, but since we've kind of worked out quantum field theory, it's just kind of fallen by the wayside. It's not really an idea that people take seriously anymore. So would the particles at CERN still be experiencing their first rotation since everything around them is slowed, assuming we could experience their acceleration? No, so they know how many times they've gone around. Like they could, if a person was riding along with them, they could count how many times they've come back to the same place. It's just that the other thing is that because they're going in a circle, they're accelerating. So in fact, their clock is running slower than the clocks outside. What is the common assertion for the beginning of the universe now? It's not clear that there even is a beginning of the universe. Have you read Sakurai? I think I used Sakurai in my grad quantum mechanics book, if I remember correctly, or my grad quantum mechanics class. Are you an astrophysicist? No, I'm a physicist. Why are people sending money? Because they want to ask questions. How much would 42? What maths do you recommend to learn physics? It depends on how deep you want to go, but you are definitely going to need calculus. And if you want to do anything in physics, you're going to need differential equations. How hopeful are you about the flat holography program and all the existing proposals? Not so hopeful, to be honest, not so hopeful. Congress said interdimensional beings exist. Congress also, said that, I don't know. Congress says a lot of dumb things, okay? Also, I think that you're probably referring to testimony of people in Congress, not Congress itself. Lots of questions, guys, so if I skip yours, I'm sorry. I'm trying to get to as many as I can. How old are you? I'm 33. What do you think of Alexander Grothendieck's program? He was brilliant. I don't understand most of it. Algebraic geometry is, or algebraic topology is, and category theory is way above my head. Is an electron orbiting a nucleus an example of quantum gravity? No. So an electron stays in place, stays in orbit, in big air quotes, around a nucleus because of the electromagnetic force. How is it that both extreme gravity and extreme speeds can slow time relatively? It's because time and space are related to each other. So this is kind of the fundamental idea behind Einstein's ideas. And so if time and space are related to each other, you can understand how speed, which is a measure of distance over time, is going to affect both your perception of space and your perception of time. And also, if gravity is the warping of space-time, then you can understand that that'll affect both space and time. From HGE Berg with the $5. Do you think AI will take the jobs of a lot of physicists due to the algorithmic nature of physics? What's your thoughts on what jobs will lose to AI? I have no idea, but physics is not really algorithmic. So, I don't know. Also, it's hard to say that it is even AI. Like, it's not like the things that we have right now are not really AI, right? Is there evidence for primordial black holes existing? From what I've seen recently, there is some tentative evidence, yes, but it's hard to say if it's definitive yet. Are you only a theoretical physicist, or do you have experimental evidence? Only a theoretical physicist? You know, Albert Einstein was a theoretical physicist, right? But yes, I rely, just like every physicist before me, I rely on experimental evidence to do my theoretical work. I've heard before that entropy doesn't work correctly in space. Is this true? It's not quite clear what you mean by doesn't work correctly, but there is an issue with how we talk about entropy in a universe with gravity. So given all of the other forces talk with entropy in a nice way, like, you know, you can describe the entropy of a system that's governed by the other forces pretty easily. But once you introduce gravity, it gets a little bit messy. From Mr. Delightful Song again with the 2,500 Chilean pesos. If time is an illusion, as I understand, does the present affect the past and the future the present? Does the present affect the past and the future the present? So likely, and well, okay, I don't want to say likely. So if time is indeed an illusion, the reason why there appears to be a passage of time is because the passage of time, or the direction of time, is just the direction in which causal events happen. So no, the present doesn't affect the past, because the present and the past are defined relative to one another, such that only the past affects the present, not vice versa. And from Keegan Pug with the $10, what are your top 5 power metal bands, and what are you listening to today? Or what are you listening to lately? So I haven't been... Okay, first I'll answer the first question. So in no particular order, Sabaton, Power... by the way, I'm a basic bitch. So Sabaton, Powerwolf, Beast in Black, Glory Hammer, Hammerfall is probably top 5 right now. What am I listening to lately? Let me open up MusicBee and see what I had open most recently. I've been listening to Beast in Black's discography. I may have missed something, by the way, as far as bands go. No, those are definitely my top 5. Okay. And from Chachi with the $5, hi Blitz, I'm taking calc-based physics in college next year, and I'm wondering how difficult it may be. I love watching your debates and streams, by the way. Well, I appreciate that. So look, calc-based physics will not be challenging, any more challenging than non-calc-based physics, like algebra-based physics, if you're comfortable with calculus. Calculus is just a language, and so like calculus is to, you know, think of knowing calculus as like being able to read like Chaucer's English, or like being able to fully understand everything that Shakespeare is talking about, whereas algebra is perhaps closer to like being able to understand, I don't know, The Catcher in the Rye. Like it's just a more complicated language. Because it's something that we're not as familiar with on a day-to-day basis. But once you speak it fluently, once you know your calculus fluently, you can kind of think in calculus. Then all of the calc-based physics stuff just becomes physics again. Are we running out of physicists? No. How useful is AI in writing your papers, or do you not use it? I do use LLMs when writing. So I use them for basically 2 purposes. One is finding references, very, very useful for literature searches. The other is kind of as a what's it called, a rubber ducky. So there's this idea in programming, like in software engineering, that it's fairly old at this point, where you just have like a rubber ducky sitting on your desk, and you would kind of like talk through your algorithms or talk through your code to the rubber ducky. And like just the idea of like talking to something can help you express your ideas and think through your ideas better. So I sometimes use LLMs in that way too. But I use that more for kind of the conceptual development, not for the actual mathematical development, because the mathematical development, it doesn't get right all the time. It's more of just like when I'm trying to like think through ideas, I'll like tell it to the LLM and have it like pick holes in my ideas. Does the universe expand uniformly around us, or is there a bias in any direction? So it seems like the overwhelming kind of consensus is that it is uniform, but there has been some evidence that suggests it might not be. No, this is pre-recorded. No, it's not. What are your thoughts on the double slit experiment, the observer effect? So the double slit experiment just demonstrates that that stuff is made of waves. The observer effect is kind of a misnomer. Really, all that's happening in the double slit experiment with regards to the observer effect is that when you take a large macroscopic system, that large macroscopic system becomes entangled with the things, with the wave that's passing through the double slit. It can become entangled in one way with the one that's passing through the right slit, and in a different way with the one that's passing through the left slit. And that entanglement means that those two kinds of waves are not the same wave anymore, so they can't interfere. So instead, they just produce two bright spots. That's all that's happening here. There's nothing spooky happening. Explain why black holes have high entropy. Wouldn't the center of a black hole be extremely ordered? The event horizon may have high entropy, but the event horizon is not the black hole itself. Well, look, the event horizon is the defining characteristic of a black hole. You don't need to know anything about what's going on inside a black hole to compute its entropy. Now, as for why a black hole should have such high entropy, well, one reason is that throwing information in, you can't know anything about it, about like the configuration of stuff that's going on the inside. The only thing you know is the total mass and the total charge and the total angular momentum. So you, in some sense, you are throwing away as much information as possible, and all that's left over is kind of like those three variables. So, and if we define entropy as just the amount of information you're leaving on the table, the amount of information that you're throwing away, then of course it's going to have very high entropy. From Git Stanfield with the $5, what are your thoughts on the many worlds interpretation in quantum mechanics as opposed to others? I like the many worlds interpretation. I think it's kind of like the minimal required interpretation that doesn't add extra stuff like wave function collapse. Did you take point set topology or algebraic topology? I took point set topology, and I withdrew from the course because I was not ready for it. Sorry, I feel like I have an eyelash in my eye. Oh no, it's just cat hair. Can you explain Hawking's theory on the beginning of time? So at least going back to the 80s, Hawking had this idea of something called a no boundary proposal, which rather than having a beginning, or rather than having a like a singularity at the beginning of time, it's more that like there is a first moment of time, and that first moment of time just gives way to only space. So there was space-time, and then it just became just pure space. And that pure space kind of just caps off in a nice round way. In the same way that there's not a beginning of space, there's not a beginning of Earth that's at the North Pole. The North Pole is kind of just like a smooth capping off. There's not like a boundary of the Earth. So Hawking and Hartle's idea is that like the universe kind of smoothly caps off, so there's not like an edge of time, if you will. And from Sheriff Slug, again with the $10, do most physicists think that time is infinite or that the Big Bang was the beginning of the universe? Oh, I already answered this. Oh, I'm a little bit... That was weird. It's showing me old ones. Okay. Well, let me jump down to the bottom again. Where are the questions he's answering from? They're on TikTok, YouTube, and Twitch. Why is the age of the universe 14 billion years, but the length is much more than 14 light years? So when we talk about the size of the universe, we're talking about how big it is now. And so even though the universe has only been, the universe as we know it has only been around for 14-ish billion years, the universe has been expanding for quite a long time, or for that entire period of time. And in fact, the stuff that is now, the stuff that the latest, the furthest away stuff that we can see, it emitted its light when it was, I don't know, 1.4 billion light years away. But the universe has been expanding ever since, and that stuff is now moving away from us much faster than the speed of light. Like the gap between us and it is growing much faster than the speed of light. And so you can get a universe that's actually quite a bit larger now than the 13.8 billion years that our universe has existed, or that the universe as we know it has existed. Blitz, I have come up with a topological proposal for the unification of gauge symmetries and gravity. Can I send it to you? No, publish it in a journal first. The universe has an age? The universe as we know it has an age. It's 13.8-ish billion years. Does the electromagnetic field produced by the human body interact with molecules outside the body? Not significantly, no. The universe is expanding? Indeed it is. If the many worlds theory isn't spooky, I don't know what is. Well, I mean, look, it might be spooky, but it's minimal. Meaning that if you just take the equations of quantum mechanics seriously, you just get many worlds out, you just get like on their own. Like it just happens automatically. Why do relativistic jets flare out at the end? I don't know. I'd have to think about it some more, and I'd have to read about it. True that a human observer isn't enough. Collapsing the wave function requires electromagnetic observer. Well, No, you just need some sort of interaction with the system. Some sort of macroscopic interaction, I should say. Do you think we'll know what dark matter actually is in the next 50 years? Maybe, I hope so. Thoughts on Turek's quadratic curvature tensors allowing for negative norm states? Seems like he's really into something. Look, I can't have read every single paper, so I haven't heard of this. So that means all of the observable universe is not the limit? Well, it is. What? It is. It's the observable universe. As you know it? Yeah, so like, look, the universe as we know it has existed for 13.8 billion years. Whether or not there was something before that is a different question. Is the rate of expansion of the universe increasing over time? The consensus is yes, but there is debate over it. Why and how does general relativity work? How is it that energy can be converted into a solid? Well, it's not that energy can be converted into a solid. It's that different fields, think of like the electromagnetic field, but also the electron field or the quark field, one of the quark fields, those fields can be excited with energy. So if you take some system, if you take some field that has some amount of energy, it can interact with some other system, it can transfer that energy over, and that can produce some kind of matter. Now that doesn't really have anything to do with general relativity. That's more of a quantum field theory thing. General relativity just cares about energy density and momentum density, really. Can you read minds now? No, that's not what psychic says. That's not what physicist means. How can the universe expand faster than the speed of light if the speed of light is the speed limit? Well, so the universe's expansion rate is not a speed, right? The universe's expansion rate is a rate. It's like think of it like a doubling size, right? If you have a sheet of paper and it doubled in size every certain amount of time, you wouldn't say that its expansion has a speed, you would say that it has a doubling rate, and that's what the universe has. If the standard model of cosmology is correct, then the doubling size for a universe currently is about 10 billion years. It takes about 10 billion years to double in size. It was much faster, like the doubling time was much faster a long time ago. It slowed down and now it's speeding back up again, and we're kind of asymptoting towards this 10 billion year doubling rate. From Gonzalesa with the 5 Canuck bucks, what would it take to play planet billiards and swap the orbits of Venus and Mars and give Venus an Earth-like tilt and rotation speed? Sufficiently advanced technology that at that point we should just do terraforming instead. Like, that's just the reality. Like, moving planets would be so challenging. Is our reality based on local rules and forces, or is there an unknown global force or glue? Well, it seems like that the local rules and forces are actually global, meaning that they're the same everywhere and everywhen. Oh. Can physicists argue in absolute terms that God doesn't exist? I mean, sure. They probably won't use physics because absolute terms is not... Science is not the... In science, we don't use the language of absolutes because we talk about evidence and data and, you know, credence and things like that. But physicists are people that can make arguments. Why does friction contribute to losses in machines? Well, because, look, you have some amount of energy that you can use for some sort of process. But some of that energy, because energy is conserved, at least on an earthly scale, some of that energy is going to go towards heating stuff up or producing sound, and that's the kind of thing that friction does. And so that means that you'll have less available to do whatever you want to do. Thoughts on the amplitude-hedron math and its implications? So I know somebody who is very involved in that, but I never got into it, so I'm not familiar with the amplitude-hedron math. Is it possible for me to publish an academic paper without being a professor or having a PhD? Yeah. I mean, I'm not a professor and I publish. I do have a PhD though. It is possible. It's just, look, the whole business of getting a PhD is not just learning stuff. It's not just learning the science, it's learning how to be a scientist. It's learning the norms of your field, it's learning how to write papers, how to do research. And so if you don't have a PhD, it's likely you won't have those skills. Not impossible, but it's just likely. Why do supermassive black holes in galactic centers always converge in galaxy collisions? So for the most part, there's something called dynamical friction, which is basically a result of large bodies just interacting gravitationally. They tend to kind of eject things, and those things carry away energy. But there is a problem that when those supermassive black holes get sufficiently close to each other, it's called the final parsec or the last parsec problem. That once they get sufficiently close, within a few light years, maybe like 10 light years or so, it's really hard to explain why they actually coalesce and how they're able to close that gap, because they're not close enough that they're emitting a lot of gravitational waves, but they're not far enough that they're disturbing a large area and losing energy by ejecting other stuff, be it gravitationally. So that's actually an open question currently. Thoughts on the speculation that government researchers developed anti-gravity levitation? It's a conspiracy theory. It's almost certainly not true. What type of math should I look at since I love math? Moreover, I know math is used a lot in physics. It just depends on what you love. So I love geometry, so I ended up doing geometric mathematics. Some people love the sneaky tricks and the sneaky ways that you can add zero, and that ends up being people who love analysis. Some people love very rigid structures and very axiomatic based approaches, and those people end up doing algebra. So it really just depends on what you're into. You are no scientist. Am too. From Mr. Delightful Song, again with the 2,500 Chilean pesos, can it be that the time illusion is just movement through a higher dimension? Past gets behind because of traveling away from it into the future. Well, that wouldn't be an illusion. That would just be Einstein's relativity. We live in in that view, we just live in a four-dimensional Lorentzian manifold where time is one of the four dimensions of space-time. From Enough Data with the $10, very generous, thank you so much. I thought the wave function collapse was from the adding of two waves to each other like a Fourier transform, the wave function of an electron combining with the wave function of a photon. No, it's not. There is no clean mathematical description of the wave function collapse. The wave function collapse is a sudden, discontinuous, if you take the wave function collapse seriously, it is a sudden and discontinuous behavior where there is an immediate transition from some smooth wave function to a wave function that is peaked at a single location. And it's not due to a Fourier transform, it's not due to waves interfering, it's not due to any of that. Oh no, I don't have my water bottle. That's a bummer. Vazaraka, thank you for sending 5 Dr. Blitz Debunks gift memberships. I appreciate that a lot. So if you don't know, just because this is helpful for people who are interested, there are a few perks if you become a paying member on YouTube or on TikTok or on Twitch, or on Patreon for that matter. They're all like $5 a month or so. The perks that you can get access to a private Discord channel. You can get access to some emojis on your preferred platform, some special emojis that have reacts and things like that. You also get access to my debate notes, which I update semi-regularly. I update with more resources, more arguments, more facts, papers, references, counter arguments, etc. So if you're interested in the kind of debates that I do, and you want to see, you perhaps want to do them yourself, or you want access to my resources, consider becoming a member. It's like $5 a month, and it helps support me and helps me keep doing what I'm doing. Do I answer questions on the Discord? Absolutely, especially if they're in the members only chat. But I do answer questions more generally in the Discord server. I'm just not ever present there. Would you mind trying to define entropy with time removed? Yeah, entropy doesn't really require time. At least the statistical version of entropy. Entropy is just a measure of how much information you're throwing away from the description of a system. Oops. So we got some cash apps that I need to read and that I don't want to miss. Give me one sec. So we have $10 from Grimlock. Grimlock is telling me to hydrate, which means I need to go get my water bottle, so I'll be right back. Don't go anywhere. Hydrate or dihydrate. All right, we got our water bottle, which I left in the other room on accident. Very much appreciated from Grimlock. And we have $2 from Robert, which is very appreciated. And then another $5 on Grimlock's for not having water nearby. That's my bad, Grimlock. I appreciate you regardless. And from Welsh Mall with the £5, just send in a donation, which is appreciated, of course. Right, so why can't a cause decide after the effect? Probability waves collapsing, choosing the cause. I don't understand the question. Can you explain acoustics in space-time? Don't you have to have an atmosphere to have sound? Yeah, so there are, well, you don't have to have an atmosphere, you have to have a fluid, right? And so there was a time in the universe, a long time ago, in the very, very early universe, 13.8 billion years ago or so, At that time, the universe was sufficiently dense that it was filled with a fluid. It would be reasonable to say that it was filled with a fluid. You could talk about its density and so on, and there can be acoustics there. And so, in fact, this is how you get baryon acoustic oscillations. From Fisher-Keltoth, respectively, why do you do this? Work disruptive. I don't know what the second question is. Why do I do Ask a Physicist? Well, it's a way of providing outreach and teaching people about physics and answering questions that people have that, look, most people don't get the opportunity to ask like professional scientists questions about their field. Like most of what people see is from headlines or from interviews that are pre-recorded. So that seems like a good reason to me. Will we ever find what a singularity in a black hole is? Maybe. If we figure out what quantum gravity is, then very possibly, yeah. How reliable are quantum computers proven to be? It depends on the algorithm. Some algorithms are deterministic, meaning that the outcome is definitive. They are completely reliable. Some algorithms are probabilistic, meaning that the longer you run them, the more likely you are to have the correct answer. So it just depends on what algorithm you're doing. How can we define time in absolute terms if it's different and relative for all observers? You can't. You can't define time in absolute terms. That's the problem. From enough data with the $5, thanks for clearing that up. Yeah, the wave function collapse sounds sus. Yeah, exactly. That's why the wave function collapse is like a continuous instantaneous it's a discontinuous instantaneous event that has no that seems to have a cause, namely interaction with something macroscopic, but it's not clear what the dividing line is between the macroscopic and the microscopic, and it just seems like an ad hoc solution to like match this observation, right? Would you ever do experimental physics? Yes, but not in this lifetime. One of the things I've realized, and you know, I'm exposed to a lot broader branches of physics than a lot of people are, just because of what I do, just because I do this outreach stuff. And I talk with a lot of people from a lot of different fields, again, because of the outreach stuff. And so what I found is that it would be really cool to be an experimentalist. The thing is being an experimentalist is an entire field. You get a PhD in this stuff. Like to learn to be an experimentalist is years of full-time learning, right? And like, I just don't have that, and I don't have the time to do that. I mean, I guess in principle, I could drop all of my current research and then spend 5 hours a day, spend 5 hours a day doing outreach, spend 5 hours a day doing like learning to be an experimentalist. But the thing is the kind of work that I do, so I don't work at a university. I do all of my work, independently, if you will. I still publish, of course, and I'm going to conferences. I'm going to a conference in like a month or so, but fortunately, the work that I do isn't expensive to do. All I basically need is a fairly expensive piece of software that I bought myself, a computer, a notebook, some pens. That's all that's required to actually do the research that I do. To be an experimentalist is expensive. You need expensive equipment, right? And that's the reality. So even if I wanted to be, I couldn't be an experimentalist and keep being kind of the independent researcher that I like being. How exactly did Einstein come to the conclusion that gravity is just the curvature of space-time? I don't know. I don't know the history of his thought process. Is most of physics coding, and how do we know it's true? No, it's not mostly coding, and we know it's true because we test it. From Git Stanfield for the last one, okay, it doesn't have to be the last one. How do we know that medium-sized star like the sun will become a red giant one day? What was the methodology to come to the conclusion? It's basically just a matter of looking at a whole bunch of stars and looking at them at different parts of their lifetime and kind of connecting the dots. Also, we can build theoretical models for the kinds of things that will happen. We know that stars exist in something called hydrostatic equilibrium, which is essentially... Hydrostatic equilibrium? No. Hydrodynamic equilibrium, I'm sorry. Hydrodynamic equilibrium is essentially you have a complicated fluid dynamics system where even though there's a lot of stuff happening, there's an equilibrium that's reached to give you a stable system. In the case of the sun, we have fusion happening at the core of the sun, which is providing, essentially, it's functioning as an energy source for the sun. It's heating the sun. And when things get hot, gases, plasmas, they want to expand. And then we have gravity pulling the sun together. And there's this balance that happens. However, eventually, the sun will run out of fuel. It will run out of fuel to... run out of hydrogen anyway, to burn in its core to produce this energy source to keep it hot. And when that happens, it will suddenly contract and by contracting, it will heat up more in the core, and it'll start to fuse helium. Now, helium burns much faster, so it produces much energy, so it'll blow up again. And so this will repeat, and the sun will get bigger and bigger and bigger as it burns more and more of its final fuel. From Sokido with the $10, which is very appreciated. Thoughts on the UAP UFO hearings and sightings from pilots? Without data, it's nothing, right? I mean, my position is, unless we have stuff that scientists are able to publicly examine, it seems like it's just vibes. Have you ever worked in a uni? Yeah, when I was a grad student, I worked at a university for 7 years as a grad student. I worked at a university for 3 years as a post, or 2.5 years as a postdoc in Europe. I finished that job last year, about a year ago, and then I moved back, and now I'm doing this because honestly it pays better and I get more independence with my research. Do you still recommend physics majors in 2026, and what's your advice for the newcomers to the major? Look, I recommend it insofar as, like, if you love it, you should do it. I understand that most people go to university to get a good job. I understand that that's a main motivator for most people because financial independence, financial security is very important. If you get a physics major, as long as you learn how to code, or you learn some other skill in addition, like maybe you get a minor in computer science, or maybe you get a minor in business or something, your skills will not be, or you getting a major in physics will not hurt you. And it will give you opportunities that you might have not had otherwise. Like, you'll get the opportunity to actually do science. Do physicists use modular arithmetic? I guess sometimes. I haven't. What does the first hour of your workday actually look like? So this morning, it was editing a video that I posted right before the live stream. So I do my science communication in the morning, and I do my research, my actual science in the afternoons. So the morning starts with editing a video or writing a script, or yeah, it's usually one of those two things. And then I do a live stream, of course. What do you make of the dark vortices caught moving faster than light speed? I haven't heard about this, so I can't comment on it. Been to CERN yet? No, I didn't have the opportunity to go to CERN. I mean, like, in principle I could have, but that would have been like a vacation, and I didn't want to drag my wife to, well, we want to go to Switzerland. It's just expensive to go there. Is it true that we can see further than we could ever theoretically physically reach? Yes. And the reason for that is kind of straightforward. The things that we're seeing, they emitted their light when they were much closer to us. If we wanted to leave now to get to them, now they're much further away from us, so we couldn't get to them. Most people don't get a job using their major. That's true. Why does Angels of Light think you won your last debate? He didn't even understand basic physics. It's a part of the delusion, my guy. I know a few physics PhDs that ended up on Wall Street making a boatload of money. That is not the norm. It is a thing that happens, but it's not the norm. What methods do your mathematical proofs usually contain? Often it's proof by contradiction or otherwise constructive proofs. Like, I just build the thing that I'm trying to prove exists, for example. I have a question. If you're not going to academia, would you suggest doing a PhD still? If you know that you don't want to go into academia, and you know what field you do, what you do want to do, and you know that that doesn't require a PhD, it's probably not worth it. Like, realistically. Have you ever found someone randomly who joined your Discord or whatever that helped you with papers? Well, somebody joined fairly recently that found an error in a paper that it hasn't been through peer review yet, so that found a few errors in a paper that me and a few colleagues wrote. Probably pretty easy to fix. We were just considering, the proofs that we were writing we were thinking very much about the non-degenerate cases, but the results generally probably don't hold in the most degenerate cases, and so we have to be a little bit more careful and specify exactly what we're doing. Any stories about meeting someone far smarter than you? Most of the people that I meet in my field seem like everybody in my field is as smart or smarter than me. maybe that's me being humble, but like everybody in this field is brilliant. What does an entry-level position as a physicist entail? Are they assigned specific projects? There is no such thing as an entry-level position. The closest thing that you'll get to is like a PhD student, but you're still a student there. It's not really like I mean, it is a job, but it's not like a 9-to-5 job that you like apply for. It's a school application. Fusion technology, how far are we from developing sustainable power? It's hard to say. Why does time only flow forward, and does it exist objectively, or is it just human perception? Well, I don't think it's just human perception, but I think it is plausibly an illusion. Sorry, let me drink some water. Why does the gravitational potential diverge in an infinite uniform Newtonian universe, and how does general relativity avoid this paradox? General relativity isn't really concerned with this paradox, right? Because general relativity is not about gravitational potential. As for why the gravitational potential diverges in an infinite uniform Newtonian universe, it just follows from the mathematics, right? If a globe can be mathematically derived as a plane, how do we truly know Earth is a globe? A globe cannot be mathematically derived as a plane. Arguing with a so-called science guy? What do you mean so-called science guy? You're smart, but you also engage in name calling? Well, when somebody's being rude, when somebody is a bad faith actor, of course I'm going to engage in name calling. They deserve it. I'm about to finish my PhD in physics and I'm flying in the Navy after. Never wanted to do academia. Well, that seems neat. From Gonzaleza with the 5 Canuck bucks, what would oh, I already answered that. I don't know why it's sending it back, but thank you again, Gonzaleza. Have you done much research into twister theory? I tried to. I don't understand it. I went to a conference specifically to try to learn about twisters. The conference had Roger Penrose, the founder of Twisters, at the conference. I came back from the conference still not understanding them, but I did meet Roger Penrose. From Welsh Mal with the £5, hi, do you know of the Nature paper saying they certified perfectly unpredictable randomness using entanglement? My mate said it's clickbait. I haven't heard of this, but it seems plausible. Like you can certify, I don't know how you certify it, but you can check for randomness. You can check for, you can do like statistical checks on randomness, and at least like whether or not you believe the world is, whether or not you believe many worlds interpretation or the Copenhagen interpretation or the Bohm interpretation, all of these things have genuine unpredictable randomness in them from quantum mechanics. So that's not surprising. Have you studied quantum mechanics? Yeah, of course I have. What is the ADS CFT correspondence and why do people care about it? Yeah, so the ADS CFT correspondence was perhaps like the first successful way of talking about quantum gravity in a way that we have the tools to do. So string theory developed in the 80s and 90s and early 2000s, but string theory is like remarkably hard, and like we don't really have the tools to do string theory properly. The ADS CFT correspondence took string theory, and it showed that string theory in a certain space-time setting is equivalent to a certain kind of quantum field theory, which we know a lot about. We know a lot about quantum field theories. And so if you can talk about string theory, which is, you know, a theory of quantum gravity, by talking about the conformal field theory, which is the type of quantum field theory, then you gain a lot. You can learn a lot about string theory just by doing quantum field theory. Similarly, there are some things that we know how to do very, very well in quantum or in string theory that we don't know how to do on the quantum field theory side. And so you can use the correspondence to kind of fill gaps in our understanding of the other side of the correspondence, and that's really powerful. Why does the universe exist instead of nothing existing? I don't know. Maybe it had to. What type of project currently gets sponsorship in the world of physics? I don't know what you mean by sponsorship. If you're talking about grant money, lots of things get grant money. Does the universe expansion ground current thought process behind the Big Bang? Yes. Do you think we'll know what dark matter actually is in the next 50 years? I hope so. Sorry, I have to jump down to the bottom because I'm very behind. Isn't string theory essentially unfalsifiable? No, of course not. Do you try and tie your pure math work into your physics research, or are the two pretty separated? To a degree, yeah. I mean, I've written a few papers even that are physics papers, but they use the stuff that I did my PhD on. So yeah, to a degree, definitely. I want to go into academia, but I also love engineering, don't really care about money. What should I do? That is a you question, my guy. What are the odds our universe is inside a black hole? I think they're very low. What do you think about the idea that the expansion of the universe is slowing? It is an interesting idea. I know it's contentious right now, so I'm going to try not to take a stance on it. Thoughts on Michio Kaku, who's my inspiration for physics? He was part of my inspiration too, but in the last 25 years, he's kind of gone off the deep end. Like people, like news stations bring him on, and then he just says like the wildest things. Interpretations of quantum mechanics with true indeterminacy, are they incompatible with the B theory of time? Not if you take the many worlds interpretation, but if you take the, well, okay, they're also not incompatible with like the true indeterminacy of like the Copenhagen interpretation isn't necessarily incompatible with the B theory of time. All it would mean is that there are things that happen in the timeline that are just uncaused. that have no like determinate cause in the past, but they could still be determined. They're just, so when we say true indeterminacy, what we mean is like genuine randomness. You can have genuine randomness, but still have everything be set in stone. From Don Craig with the $5. Thank you so much. I love algebra and calculus, but not geometry, but I think it's because I wasn't taught why. Do you know a good online course that explained why? That explained why you should love geometry? I don't know what the question is. I don't know of any good online courses for really anything. I've never taken an online course. I've never designed an online course, so it's really hard to say. But geometry goes a lot deeper than what you learn in like 8th and 9th grade. Like the geometry, like the way that we talk about general relativity is geometry. That's the geometry that I love. And so if you can get behind the bending of space-time causing gravity, and the reason why things fall is because space-time itself is bent, that's a geometric idea. And if that doesn't motivate you to love geometry, I don't know what will. I don't think the center of a black hole is infinitely dense. That's just not possible. Okay. Isn't many worlds model actually superdeterminism? No. Would you want to meet Albert Einstein? Yeah. Is there a definition of time that everybody can agree upon? Probably not. From El Jasone with the $10. I appreciate that. As a fellow scientist, PhD physicist, and teacher, I do not know how you remain calm when dealing with flat earthers. Their arrogance and ignorance hurts my brain. You deserve a medal. Well, look, so you have a PhD. You're a teacher. You've taught engineering students, presumably. Engineering students are some of the most arrogant and not that this is a bad thing, this is kind of normal. They're some of the most arrogant people that you will ever meet. Not all of them, but some of them. Because these are the kids who were the smartest kids in their class, and they think they know everything. And obviously they eventually grow out of it as they take more advanced courses. They learn what they don't, or they find out that there are a lot of things that they don't know, and they become more humble, and they become more, normal as they become more fully fledged adults. But you know what 18-year-old engineering students are like. That's what flat earthers are like, except the flat earthers don't actually know anything, whereas the engineering students at least do know something. That's the secret. And I taught engineering students for years. Would it be plausible to equate physics to chess in terms of pro? I don't know what that means. Does Gödel's incompleteness theorem factor into physics very much? Not in my view, no. Is faster than light travel possible in 1,000 years? Look, it says physicist, not psychic. I can't predict the future. Angel destroyed you ein week ago. Well, that's not what the YouTube comments seem to say. The YouTube comments on the YouTube video that has over 10,000 views on it, everybody is making fun of Angels of Light, man. So I don't know, man. From Snowcat with the $10, I appreciate it. You have the most hysterical way of insulting people where you are ridiculously verbose but still incredibly sassy, and I love every second of it. Look, that's my kind of humor. It's very, and so I'm glad that somebody else enjoys it. Presumably, though, Blitz, engineering students are more tolerable than flat earthers in the arrogance. Yes, that's true. They are. Because they do recognize that they are there to learn. Yeah, you're usually their first humbling experience. Yep, that's exactly what happens. And then you know what? Then they chill out. Like the first time that they get like a C on a test, they're like, oh damn, I need to lock in and pay attention. So I recently learned in my physics class that light waves are made up from wavelets. How true is that? Well, a light wave is a light wave, but you can always decompose it into something into kind of smaller pieces, and you could call those smaller pieces wavelets. A defensive evolutionary theory is the would you call gravity a theory? Scientific theories are the strongest we have, yet I hear that string theory is not well accepted. Can you expound? Yeah. So this is an unfortunate consequence where the science communicators have actually said something that's just probably not true. So I expound on this a lot because this is something that even people that I very much respect and appreciate, like colleagues and, you know, acquaintances, do this, where they talk about how a theory is the highest thing in science. Like, it's just not. So to a science communicator and to the lay public, you should understand the scientific theory as the kind of thing that has a whole bunch of evidence supporting it, and has been empirically tested and verified over and over again. But when scientists use the word theory, like physicists especially theoretical physicists, it's like just a model. It's just a model that has some sort of physical interpretation. And that's what string theory is. String theory is a model that has it's like a mathematical model that has a physical interpretation. And then hopefully, if it becomes verified, it'll become the standard model. And standard model is probably the phrase that's used to describe kind of the consensus view in a certain field. So we have the standard model of cosmology, we have the standard model of particle physics. These are the things that would be adequately called, a scientific theory if you're using that definition. But scientists, at least the ones that I talk to and the ones that, you know, the papers that I read, they don't use the word theory in the way that science communicators do. From Marky with the $5, what's your favorite scientific topic to learn about? Generally, it has to do with weird topology at the beginning of the universe, if there is a beginning. And for Music Dance Mashup with the $5, do you think it's important for STEM majors to also take some humanities classes? Did you have a favorite humanities art elective class? I do think to some extent that it is important. So I took, it depends on what you consider humanities. So the university that I was at, I was part of the honors college, and part of the honors college was something called the human event. You have to take 2 semesters of this course, which is basically just reading the classics, discussing the classics in kind of a seminar style. It was really hard. That class is famous for being hard at the university that I went to. Like, it's famously like a challenging course. So I'm not sure how much I loved it, but I did like the opportunity to read those things. A class that I very much appreciated was a class that I took on world religions, and that it gave me a lot of perspective, and I learned a lot in that class, and I really enjoyed it, and the professor was excellent. So probably that class would be my favorite. And yes, I do think that it's valuable to take humanities classes. String theory is mathematically beautiful and consistent, but there's no evidence for it yet. Is this accurate? In a sense, it's accurate, but so in a sense, it's inaccurate. One could say that there is evidence for it, but that the evidence is not distinguishing for it. So you could say that all of the evidence for the standard model is evidence for string theory, because the idea behind string theory predicts the standard model. It also predicts like a whole bunch of other stuff that we haven't detected, but it predicts the standard model. That was like the whole point. And so that is evidence for string theory, but it's not evidence that would distinguish it from just quantum field theory. So it's not distinguishing evidence that shows that string theory is indeed the only thing that is consistent with the data. From Marky with the $10, what does the universe expand into? To me, at least, expansion requires more space to expand into, but from my understanding, space isn't growing in overall size, yet it expands at every point. So space is all of the places that you can be. So there aren't any places that are not already part of space, right? The universe, when we say the universe expands, what we're saying is that space itself is expanding. And space is all of the places, so there's no places outside of the space that it expands into, because to be a place would be to be in space, which would mean that it's not out of space, it's in space. So when we say that space is expanding, what we mean is that if you could somehow put push pins into space-time, what you would find is that those push pins would get further away from each other as time goes on. Like if you imagine a grid, a space-time grid, that's those grid squares are getting bigger. Now the universe could be infinite and that could still be true. The universe could be infinitely large, I mean. Hi, does our universe not have to be emergent? It has to be in a greater structure now? Well, it doesn't have to be. What do you think about the big crunch theory? I think it's like, well, okay, I don't like the idea of the big crunch. Is it something that like I think that we shouldn't rule out? Yeah, sure. How do we know laws of physics are eternal and universal, not just local cosmic habits that change? Well, we can see, so if they are local, then they're local on a very large scale, because we can see other galaxies that are billions of light years away, and those galaxies have the same telltale signs of the same stuff that's going on in our galaxy. So if the laws of physics were changing with time or with space, then we would expect that distant galaxies would look different from how nearby galaxies do. But they don't really. So, but string theory predicts the standard model of other universes, not necessarily just ours, so it's physics philosophy. It's not physics philosophy, it's just a physics framework. So, to be clear, quantum field theory does not predict our universe. As like quantum field theory is a framework. You have to provide input models. You have to kind of like take that framework of quantum field theory and then work out the specific details to figure out which quantum field theories describe our universe. Likely the same is true for string theory. If string theory is correct, that is, of course. I thought the Bell experiment broke locality. It broke locality, or it broke reality, or it broke, there's something called, what is it called? It starts with a C. I don't remember. Basically, there's one of three. It broke at least one of three things. What are your thoughts on never knowing the one-way speed of light? I'm not too worried about it. Is it possible to intuitively understand the universe, or should it be more of an abstract understanding? I think that once you work with the ideas enough, I think they become intuitive. So yeah. What are your thoughts on recent research on CPT violations with antimatter? I haven't heard of this. Speak on the scientists that research anti-gravity. There is one scientist that could be confirmed to have been working on anti-gravity. Her name, she was Chinese. I think she was Chinese. She was like a Chinese American. And she was working on it in the 90s, and then her work didn't really pan out. She ran experimental tests and her theories were falsified. And then she was hit by a car like 10 years later. I don't remember her name though. I made a video about it a while ago, so check it out. It should be in my debunking playlist. But yeah, anti-gravity, like it doesn't seem like people working on anti-gravity is a real thing, with a few exceptions. Yeah, she was hit by a car. It was like a tragic accident. It happens sometimes. I don't think, one sec, let me remember her name. Ning Li, her name was Ning Li. She died in 2021. She was working on this anti-gravity stuff in the 90s, and she like published this work, right? Like, this is published work, you can go read it yourself. This is stuff that like people were really taking seriously. She had a theory. She proposed this theoretical framework that involved superconductors and stuff, and then she worked with an experimental team to test it, and it was wrong. The theory was wrong. And so, she stepped out of the public eye. I imagine she continued to research, but nothing really came of it. And then what happened to her? She was, by the way, she was old, and so she was born in 1943. She was hit by a car in 2014, so she was 71 years old. She was hit by a car. This is more than a decade after her anti-gravity research. And then her husband had a heart attack. She wasn't killed by the car, but it did cause permanent brain damage. She suffered from Alzheimer's, and then she died at 78. Like this happens. People sometimes are hit by cars, unfortunately more often than it should happen, but I don't think that necessarily has anything to do with. No, this is not the Chinese chick with the Cobalt 60. That's different Chinese American physicist, or different Chinese physicist. Also, put respect on her name. Her name is Madame Wu. How educated are you on nuclear physics? Because I never hear you talk about the subject. It's just not an area that's super interesting to me, and I've taken a few classes on it, of course, and I've read a bit on it, but it's not super interesting to me, and it's also not something that I know the ins and outs of, like I know the ins and outs of relativity. How is there more matter than antimatter? There must be a symmetry violation, right? Yeah, there must be. That's one of the biggest open questions. There was a concern in the peer review process in general for instance fields like psychology. Probably a dumb question, but is this applying to the harder fields as well? It depends on the field. There is a So, okay, the problem in psychology is that there's often not reproducibility. The peer review process, I don't know if there's an issue in the peer review process. The peer review process in physics, I haven't had a bad experience with it. The only time I've had a bad experience with it was when I submitted a very, very long paper. And this was in mathematics, actually. I submitted a very, very long paper. It was like 70 pages. And there was an error in it that neither I nor my collaborators nor the referees, the peer reviewers, there's an error that nobody caught. But that happens, and I don't think that that's like a problem, so to speak. I think that that is like the kind of thing that you expect to happen, but peer reviews try to reduce that, try to prevent that from happening as much as possible. Does category theory have applications in physics? I know of at least one person who's trying to do stuff with category theory in physics, yes. What is the difference between a PhD and a doctorate? All PhDs are doctorates, not all doctorates are PhDs. Anything new left to discover in physics? There's so much. Does ADS-CFT change how you think about bulk locality, or is it still emergent at best? So I think about bulk locality in a very classical way, but when I get down to the nitty-gritty, I start to think about how bulk locality might just be emergent from something more fundamental like entanglement. Nuclear physics is harder because we don't have a master equation. Instead, we have an empirically derived equation and is model dependent. That's true. That's also true. Yeah, it turns out GR is just like really, really, really good. And nuclear physics, but that's because GR is also really simple. Like space-time is a fairly simple thing, whereas nuclear physics is really complicated. I heard most papers are BS. I wouldn't hold that position unless you're in the field. Why does our universe prefer symmetries? Why is Noether's theorem true? Well, Noether's theorem is like a mathematical truth. If you want to know why it's true, you can go read the proof. Now, why our universe prefers symmetries? I'm not sure if our universe prefers symmetries. I think that that's just like an elegant way for us to describe the universe. Are virtual particles actually popping in and out of existence? Not really, no. Do you have a demo or analogy that you think helps a non-physicist understand how matter bends the time component of space-time? No. The thing is anything that I try to show you will be in space and not time. With perhaps two exceptions. So there is a paper that somebody wrote a few years ago, I want to say. Maybe it was a while ago, actually. And I made a video about it. It's called, if you want to find the video, just search Trumpet of Time and then my username on whatever platform, probably TikTok. So there is a way that you can kind of translate the bending of time into instead bending of space, and then straight line, and then you can kind of just coordinatize the spatial direction, and that'll be a time. You just call that time. And so you can visualize the bending of space, or the bending of space-time that way. There's another guy, and I want to say it was Veritasium or something, or maybe it was Smarter Every Day, who made like a device, like a physical thing that kind of demonstrated this, and I'd have to go find it. But I want to say it was like a... Let me see if I can find it, just so that I can refer to it. It was like a bunch of strings. Is it Veritasium, maybe? It was like a big device. And it was this is an old video. And I wish I could find it. But I cannot for the life of me find it. So good luck. It was like a big grid made of a bunch of strings, and those strings could like be twisted and stuff, and it's hard to explain. From Hamdi Texi with the $2, do you think there's any good arguments for theism? I think that there can be good arguments. I think that probably the most compelling good arguments are going to be those arguments that, or the most compelling reasons why people end up believing are probably going to be personal experiences. at the end of the day. And from DZB with the 249 Czech crowns, which is very appreciated. What would it mean for our understanding of reality if the universe turned out to be fundamentally discrete? It's a good question. It would mean that Lorentz symmetry is fundamentally violated at some level, which would mean that we know that relativity breaks down at some level. And then we would have to figure out exactly how it breaks down and how relativity emerges as you zoom out. So it wouldn't necessarily change our... what it would mean is that we would figure out more about how the universe works. Is that Greta with a beard? It could just be a dude. How different is Blitz's Trumpet of Time from Gabriel's Horn? They're different, yeah. What do you think is at the Planck length? More universe. It's just smaller. Can I list you as a tax write-off? I don't know. Ask your accountant. How do you feel about the black market groups that publish peer-reviewed fraudulent research papers? It's cringe and they should stop. How do you feel about us being 1/1000% into the heat death of the universe? It's false. There is no definitive time where we get to the heat death of the universe. What part of Prague did you live in? I never lived in Prague. I lived in Brno. From Robert Wallace with the $10, why is it reasonable to think that the universe might be infinite, space or time, when we have never measured anything infinite or anything remotely close to infinite, and it causes so many paradoxes? Well, it doesn't cause any paradoxes, not as far as the physics is concerned. Furthermore, the simplest possible universe is a universe that extends in all directions indefinitely and is spatially flat. And when we make observations about the way the world is, the universe is spatially flat, or at least it's damn close to it. It's hard to say if it's actually spatially flat or if it's just so big that it looks like it's spatially flat even though it's not. Spatially flat means not two-dimensional, but it means that the Riemannian curvature of the universe is, or rather the intrinsic curvature of spatial slices of the universe is 0. Which, you know, there's a technical definition for this. And so if you take a universe that is spatially flat, the model or the topology of that universe that is simplest is going to be the one that is infinite. It's just the simplest. It has the fewest built-in assumptions. It has the fewest free parameters. So given that we take Occam's razor seriously, that is the simplest explanation for the observations that we have, so we should take it seriously, and in fact I think it's quite reasonable. For what it's worth, just be like, if the universe is spatially infinite, that doesn't mean that you would ever expect to be able to measure anything that is infinite, right? It just means that there's more universe in any direction forever. But I don't see what's so far-fetched about that. Does a flat universe imply an eventual heat death? Not necessarily, but it does make it more likely. Classical mechanics is notoriously hard at my uni. Any exam studying suggestions? Well, I don't know what your university is, so I don't know how I can provide you with studying suggestions or exam suggestions. But yes, I do play Kerbal Space Program, and in fact, starting this Saturday, I will be doing it again on the weekends, on live streams. From Pensive with the $20, always being so kind, just sending support. Keep doing you, Doctor. I appreciate it. I will. What's the name of Sean Carroll book that you recommend? It's called The Biggest Ideas in the Universe. From Literally Lou with the $5 Australian. It's very appreciated that you sent the $5 over. Thank you so much, Lou. Always good to see you. Thoughts on it from Bit that the fundamental objects of the quantum field is a binary state or behavior leading to everything else we observe? I'm not convinced. But I'm glad that some people are working on it, because this is how you get to good ideas. You have a bunch of people working on different things. You said someone found errors in one of your papers, so how common are errors in peer-reviewed papers? Well, you can only ever quantify how common errors that have been found are, and errors that have been found are not that common. Who knows if there's more? I don't understand how the expansion can be speeding up. What would cause that? So if you can understand why if a universe was expanding and it was slowing down because gravity pulls inward, then just think of the opposite of that. I mean, in some sense, if dark energy, like whatever dark energy is, it has an anti-gravity effect. So it would push outward. Have you ever played Factorio? Yes, that game is like crack to me, and so I refuse to play it anymore. It turns out that if you put me in a situation where I get to design trains and train routes, I lose weeks of my life. Why do people say the path integral picks the state? Well, it doesn't pick the state. What it does is it tells you the states that are more reinforced and the states that are less reinforced. Does lambda CDM work with flat Riemannian manifold? If you mean spatially flat, yes. If you mean that it has like a intrinsic curvature, like the spatial slices have an intrinsic curvature of 0, then yes. I should say the co-moving. The spatial hypersurfaces determined by co-moving observers has intrinsic curvature of 0. That's called neurodivergence. Indeed it is. Turns out I am weak to trains too. Just not real life ones. Is the heat death of the universe predictable? Well, yeah. It's just hard to say if that's what's actually going to happen because we don't have sufficient data to come to that conclusion, in my view. Where does all the time go? Into the past. Oh. Couldn't some dark matter similar to ether potentially explain the dark matter question? Couldn't some dark matter explain the dark matter question? Well, yeah. Dark matter would explain the dark matter question. Stop pretending you actually understand everything I'm saying. If I'm saying it, I understand it. I will otherwise tell you that I don't understand it. Sorry. Can we continuously split particles forever, or is there a limit? We don't know. We just don't know at the bottom. Is fire as common as water in the universe? Probably not. Fire is a little bit more of a complicated thing because it requires certain kinds of chemicals coming in contact with each other while also having, you know, some sort of heat source. So that's almost certainly fire is not as common as water. What would be possible if the brains of highly specialized experts are connected deeply? Say, for example, highly specialized experts on quantum physics and pure math. Would that unlock new frontiers? Maybe. What kind of green screen do you use? A literal green screen. It's literally a piece of fabric that's green. I saw your space expansion and contraction video. Any new update? No. Isn't everything technically just a theory? No. Can you explain how E equals mc squared is a simplification of a larger equation? Yeah, the equation is E squared equals the square root of the momentum times the speed of light, all squared, plus the mass times the speed of light squared, again, all squared. From Stinky Ethian with the $5, what's the lamb shift version of the Casimir force being seen as relativistic van der Waals? Also high. Hold on, I need to parse this question. The lamb shift version of the Casimir force being seen as relativistic van der Waals? I don't understand the question. I'm sorry. DM me. DM me on Discord or something, and maybe you can explain the question, what you're asking, and I'll answer there. Yeah, I don't know what that question means. I don't know what the lamb shift version means. Are the funding cuts for scientific research that the news are palpable about truly palpable? Indeed, they are truly palpable. Palpable. That's a fun word to say. What does mathematical physics do compared to particular physics, to particle physicist or nuclear physics? It's just a different kind of way of approaching the science. Mathematical physicists will often use or be motivated by physics problems and then prove mathematical theorems about them. So it is 10:30. You know what 10:30 means? 10:30 means that I'm going to shift the live stream over to subscriber only mode for chat for chat, and I'm also going to start taking guests. We have one more super chat before we do that. From Marky with the $5. What are some scientific breakthroughs you think are likely to occur in your lifetime? I can't predict the future. Why do people ask me to predict the future? I cannot. I cannot predict the future. I don't know. I wish I knew, but I don't know. So if you are a paying member, then you'll still be able to chat, no problem. It's like $5 a month if you want to become one. You can still watch. Anybody can still watch. I still will take people up to ask questions in the multi-guest on TikTok and on Discord. But what that does mean, so here's the Discord link, by the way, if you want to come up and ask a question. You can also just join on TikTok as well. I will be taking guests from there. However, I do have to reset the... one sec. I do have to reset, I believe, TikTok. And YouTube has to be, I have to go in and do a thing. So give me just a minute. Usually I would be ending the live stream at this point, but I figure I can keep the live stream going and also give members a reason to stay members. It's good motivation to stay members if you want to get, because then basically your question is guaranteed to be answered because there are fewer questions. So if you ask a question in the text chat, you will be essentially guaranteed to get your question answered if you pay you just support me with $5 a month. It's not much. So I'm going to restart the TikTok live stream really quick, and I'll be right back in 2 seconds. 2 shakes of a tail, if you will. There we go. We are all set up. We're all fixed. I'm just making sure that I'm not missing anything. Sorry, and we should be all set, all good to go in that regard. Disconnect, connect. All those things should be set. Okay, we're good. We're good. We're Gucci. All right, let's answer some questions, and people will trickle in on TikTok as well. Fine, I'll superfan you. Lou, aren't you a subscriber somewhere else? Aren't you already a subscriber? If quantum mechanics is linear, where does classical irreversibility actually come from? Probably from the spreading out of entropy is my take. Or the spreading out of entanglement, if you will. It spreads out across the whole universe fairly quickly, or at least across the local area, and that gives us a, like, you know, all of the photons that are emitted, you can't go and collect those, and so when you look at the system, now it looks like something irreducible has happened because all those photons are gone. What are your thoughts on galaxies seeming to have a preferred rotation direction? Well, I'm not sure if that's true. It's something that's definitely worth talking about and worth thinking about. There was a computer scientist who made that claim fairly recently. I don't know if it's actually true, but if it is, then we definitely need to start incorporating that into our model, because that's a big deal. All right, let's bring up a guest. Oops, this is the wrong button. All right, let's bring up Zeno to answer some questions, or to ask some questions, rather. Zeno, how's it going?
Hey, what's up?
Not a whole lot.
How about you?
I'm doing all right. What questions you got for me?
Good. So I have a question about quantum mechanics. Does quantum mechanics sort of disprove like hard determinism, necessitarianism, like these types of things?
No, so it doesn't disprove necessitarianism. It might disprove determinism, and that depends on your preferred interpretation of quantum mechanics. There are versions of quantum mechanics that are deterministic. For example, the many worlds interpretation is a deterministic model of quantum mechanics. But even if you lose determinism, you can still have necessitarianism. Namely, you can still say that, like, look, this had to happen. It just doesn't have a cause as to why it happened.
Makes sense. Okay.
That it just necessarily had to be this way.
Yeah. It's actually fun. So I was looking at like the axiom of choice, and
Yep.
I found that you can have like necessary things produce contingencies. So I kind of
How does the axiom of choice get you there?
It's called the Hausdorff maximal principle.
Is that equivalent to the axiom of choice?
It's one of it's similar. It's all under ZFC.
And I don't know how you get contingencies. The Hausdorff maximum principle is an alternate and earlier formulation of Zorn's lemma, proved by Felix Hausdorff. It states that in any partially ordered set, every totally ordered subset is contained in a maximal totally ordered subset, where maximal is with respect to set inclusion. So how do you get to contingency here?
So okay, contingency. What I meant there is like, you can have. So the way I'm trying to do it for that modal collapse issue we were talking about like a few weeks ago.
Yep.
So it's like, okay, you have max, like suppose a function type thing called like max g, and then we have like w1, w2, w3, so on in this, I guess, set. And necessarily, you could say like, okay, we can God wills from this max g function, God wills like some world within this thing, and you can still have necessity there, but you can have like some sort of lowercase c, I guess, contingency. The vocabulary is still very early. But like,
I don't see. Maybe I just don't follow. But like, it seems like if a choice is being made, then that choice is either necessary or contingent. If the choice is necessary, then what follows from it is necessary. If the choice is contingent, then it has either a cause or it's brute.
This is where I would have to give. This is like something I just studied yesterday, because I was talking to a mathematician about this, and he brought up like this might help. Then I'm like, okay, I'll look into it. But of course, he's not religious at all. So I mean, he didn't have anything to say about it. But I mean, yeah, this is. I emailed Bruce about it. He emailed me back. So maybe I'll have something for you. In like 2 weeks or something. But yeah. Last question.
Sure.
So I'm still going to do a physics major, but my question is like, okay, if I want to do mathematical physics, ideally for my PhD, can I do that with just a math bachelor's and like maybe some physics coursework, or would I have to like?
I would suggest at least do like a double major is definitely the thing that you should do. But if you don't want to do a double major, at least do a minor in physics.
Okay, because
mathematical physics, well, you can go mathematical physics from two routes. You can either do it in a math department, a math PhD program, or a physics PhD program. You actually might get closer. It depends on which side you want to lean closer to. If you want to lean closer to the math, then you go to a math department. If you want to lean closer to the physics, you go to the physics department. So it just depends on which kind of department you want to do your PhD in.
Makes sense. Yeah, because where was I going? Oh yeah, like I want to do some philosophy classes, but like I don't know if I'll be able to do that with the double major.
Philosophy classes fulfill gen eds, by the way, often. So.
Oh, okay. So
yeah, so that's helpful. Yeah.
Okay, that works actually then. Okay, yeah. I mean that's pretty much it. If I develop some more stuff on that principal thing, then let you know. Maybe I'll join the Discord or something. I saw that you answer questions on there.
By all means. All right, take care, Zeno.
Thank you.
Of course. All right, we have some super chats, and we'll answer some questions in chat, and then I'll bring up the next guest. From Dizaby, again with the 249 crowns. Okay, Mr. Physicist, how many fingers am I holding up? 4. What if I was right, though? Hold on, I gotta scroll up a little bit. Okay, so we have a few questions. Did you see a recent paper? Sorry, I want to make sure that I don't miss it. Did you see a recent paper in Nature Physics showed that darkness can move faster than the speed of light? Can you explain? I didn't see that. And it seems like the kind of thing that's like a bad headline more than it is like actual science. How are tensors used in differential geometry? So tensors are super handy in differential geometry because you can describe geometrically determined quantities that still depend on a choice of coordinate. What tensors allow you to do is they allow you to describe that thing in a coordinate independent way. So you're talking about some geometrical thing, and the coordinates just tell you different ways that you can talk about that same thing. So tensors, because they have this property of transforming in a certain way, they let you do that. And for negatives, always one more slot for negative. 0 takes a slot from the positive range. Oh, I don't think that was a question for me. Just making sure I didn't miss any questions in the chat. How much wood could a woodchuck chuck if a woodchuck could chuck wood? 42. It's 42. And from Dizaby with the 249 crowns again. Wrong, I wasn't holding up any fingers. Physics equals debunked. True. Very true. Physics has been debunked, everybody. All right, let's bring up Depressed Clown. I believe that they were next. Depressed Clown, how's it going?
Good, man. How you going?
I'm doing all right. What questions you got for me?
Um, I watched that video about the contraction and expansion of space, and what does that mean for time?
Which
Well,
video?
not time.
I imagine I've made a I imagine I've made a few. Which one in particular?
It was the one with the Korean scientists that were
Oh, they
refuting.
weren't talking about the contraction of space. So
Oh, okay.
they were saying that the universe's acceleration, or that the universe's expansion, is decelerating, meaning it's still expanding, it's just slowing down.
Oh, okay. And does that mean anything for how old the universe is?
It depends. It might. It depends on whether on how it affects the way that we kind of calibrate things. And so if their conclusions are correct, then it might. It shouldn't have too big of a change. But you'd have to work out the details there, and I don't know if anybody has.
Okay, thank you so
given their
much for
assumptions.
answering my question.
Yeah, of course. Thanks for being here. Attorney greater than physicist for mind reading, apparently. Yeah, probably. That seems about right. I want to make sure that I have, okay, everything is still open. All right, we have Neil EO5K. Neil Leo 5K. Leo, how's it going?
Hey, how's it going?
I'm
trying
doing
to
all right.
understand Hawking
Go ahead.
radiation.
Sure.
So I understand, it's really because of there's virtual particles that come to existence near the event horizon of a black hole, and the black hole can take the antiparticle, which will steal the mass of the black hole. Correct me if I'm not getting this right. I'm sure you will. So I understand, if the black hole takes the antiparticle, it's going to steal some mass from the black hole. But wouldn't there be a 50-50 chance of the black hole getting the particle versus the antiparticle? So why would it radiate over time? Wouldn't that kind of even out?
So first of all, so this picture of particle antiparticle popping into existence near a black hole, and then one of them falls in, the other one escapes. That's there's a way to take that and then interpret it in the correct lens to make it true, but in a static in a stationary black hole spacetime, that's not literally happening. Particles don't pop in and out of existence. Virtual particles are not real. The picture that you want to say, which this is a way of making sense of that, is that suppose virtual particles are real, that particles pop in and out of existence all the time. What happens is that one of them, whether it's the particle or the antiparticle, falls into the black hole, and by nature of the black hole, in some sense, switching the direction of space, or switching space and time with each other, the particle that enters the black hole will have negative energy. Whether it's the particle or the antiparticle, it will have negative energy because black holes switch space and kind of flip space and time relative to one another. And so the particle that goes out has positive energy, of course. Most things have, or everything has positive energy in a normal space-time. Inside the black hole, it'll have negative energy, so it'll contribute negatively to the total energy of the black hole, and then that energy is therefore in some sense carried away by the distant particle. But a better way to understand this is, and I don't know why this isn't used as a better explainer, is just think of the inside of a black hole as being classically you can't escape a black hole, but we know of something in quantum mechanics that allows you to overcome things that you classically could not overcome. This is called quantum tunneling. So you can think of Hawking radiation as just stuff inside quantum fields just tunneling outside. And then it's kind of obvious why they're losing energy. There's stuff from the inside getting to the outside.
All right. Still trying to understand it, but definitely appreciate the insight there.
Of course. Yeah, I have a few videos on Hawking radiation, one specifically on the quantum tunneling kind of interpretation. So maybe check those out. It might help hearing it again.
Absolutely.
Of course.
For sure.
All right, good
definitely
luck.
Will. Thank you.
Take care. I actually, I need to hydrate more. Let me see if my lovely wife will fill up my water bottle for me. Water bottle. And then I need the sad eyes emoji. There we go. All right. Let's bring up Wicked Dancer. Wicked Dancer, how's it going?
Hi, Blitz. How are you doing?
I'm doing all right. What questions you got for me?
Well, I'm saving up to start some studies on my own. I really wanted to go into science. Like, I'm loving all of your posts. You're a really great inspiration. But I'm having some trouble wrapping my head around some understandings. So I want to do some astrophysics, but I'm also looking into particle physics in terms of how the fundamentals work. To understand, like, the electron fundamentally is just an excitation of the electron field.
Yep.
And would that be across all other fundamental particles?
Yep.
So fundamentally speaking, physically, everything is just a bunch of fields being excited and interacting with those excitations.
Yep.
And would that be these fields? Could you think of them as being almost like a three-dimensional fluid medium?
No, I
medium?
wouldn't say that they're. I wouldn't say that they're a three-dimensional fluid. What you can think of it as. I wouldn't think of it as a medium either. A good example of a field that everybody's going to be familiar with is temperature. So temperature would be an example of a scalar field. Namely, that it has a value at every point in space and time, at least, on Earth. Like, maybe the temperature is not well defined in certain situations, but if you like go to a place on Earth, there will be a temperature at every location at every moment in time. That would be an example of a field, but that doesn't make it a medium or like a.
It's not connected. I mean, because I figure that's what string theory was trying to convey, is that everything's connected by string.
It's not quite that. Yeah. String theory is very complicated, so much so that probably every single lay explanation will be wrong in some way. But as far as quantum fields are concerned, you should think of them as additional descriptors of a point in space-time. So a point in space-time, you can describe it with 3 spatial coordinates and a time coordinate. So 45 degrees west, 12 degrees north, and then altitude of 2 meters, and then some time. The field is just an additional set of 20-ish numbers that you would specify in addition to that. Like, once you give me those 4 numbers, you can also determine those 20 extra numbers by various measurements. That's probably how you should think of the field.
But then you would say the space-time field is fundamentally one large 3-dimensional medium.
It's not clear that space-time is a field. That's a much deeper question.
All right, I'm really looking forward to starting some studies on this, because I'm just starting up, and you're helping me a lot with your content, and I just appreciate it.
Of course.
Thank you very much.
All right, good luck, man.
Keep doing what you're doing. Cheers.
All right, I'm gonna hydrate some really quick. Kumlok needs to send money to remind him. No, I remember. I'm actively thirsty. I just was talking to somebody. Okay, we're good there. Sorry, I'm just checking some stuff. I hate Expedia ads. I get so many emails from Expedia. Anyway, okay. Where was I? Okay, so I didn't miss any questions. Let's bring up another guest. Let's bring up Sam SCD account.
Hello?
Sam's second account. I see what you're doing there. How's it going?
Yeah, sure. I was wondering about if I could get some advice of like the process of learning physics as a whole, if that makes sense.
Yeah, what stage are you at?
I am just entering my second year of A level now, right? And I'm wondering what would be the best way to pursue it.
So I have no idea I have no idea how A levels work. I know vaguely what they are.
I can tell you like topics, I guess, if that helps.
So I won't be able to give you any topic specific advice because I don't think that there is any.
Well,
what
my
is the
point
case?
is more.
Go ahead. No, you're good. Go ahead.
Well, essentially, in my school, there's like a big culture of you. If you want to learn something at a high level, you would go to uni. And I'm
Yep.
wondering your take on like learning things at home. So
Oh no, you will
can
be
find a
far
lot
more.
of-
You'll be far more successful at university.
Really?
Yeah. So
I found for maths, I've learned it a lot better than I have at school at home. Like I've done a low level uni course.
So
in
I
math,
should
and it wasn't
so
too
I should
bad.
say that what is the case is that the number of people who have successfully self-taught themselves physics to be competent, to be the equivalent of a university degree, the equivalent of a doctorate degree, in today's era, like in the year of our Lord 2026, if you will, I would say that it's probably close to zero. Very,
do
very
you
few
think that
people
could be
will be
like
successful.
Do you think that could be like a problem of induction thing, where as we get more and more information online, eventually people are going to start becoming self-taught? Like, I guess you
no,
could
I don't
say
really
there's a
think
bit
so.
of a
I mean, like
there-
maybe
no,
it
there's
will
a
be
bit
the
of a
case.
sampling. There's a bit of a sampling bias, though, I think, because you could say that the most talented people go to uni anyway, I guess. So,
Look,
like, a
so
self-taught
all I'm
person
saying is
wouldn't be in that demographic.
all I'm saying is it turns out being surrounded by people who are interested in the same topics that you are and having access to experts in the field that you can just go walk into their office is a very, very useful resource. And that's just sitting on top of the structure that you get and the decades of experience that you get from taking courses like at a university rather than just trying to do it all yourself. Like, if you can do it at a university, I don't see why you wouldn't. It seems like it wouldn't
Well, it's
hurt you
more
at
like
all.
it's more like it would be quite a big financial commitment. And
That's
if I could
that's
get
fair.
if I could get the same thing from like maybe forums in terms of conversations, maybe like Discord servers, maybe
So
online videos of lectures, I'm
what-
just wondering whether or not it
So
would make sense.
it depends on what you want to do with physics. Like, if you want to learn physics just because you're interested, then
I currently it would be just because, but I
Well,
would like to get to
sure.
a good level. Like, if I
mean-
had the opportunity to change anything in physics, I would like to do that. You know.
So, and again, it's not impossible, but my suspicion is that there are currently the number of people who are currently alive who do not have a formal education, like any degree of formal education in physics, who have made meaningful contributions to physics could be counted on one hand. That would be my guess. So if your goal is to meaningfully do physics and like contribute to the science, then it seems like the most efficient way that we have figured out how to do this is through a formal education. Now, it's not to say it's impossible and things might be changing.
Well,
So
would
maybe
you
you're right
say
about that.
that-
But like,
I
if you
think
just
this
want the
might be,
statistical likelihood, then that is the way to proceed. Although I do
Well-
understand that there's a huge financial burden.
Yeah, but can you kind of get behind the idea that the world changes very quickly, and with things like, I don't want to say AI
does,
because I'm
but there's
guessing
no guarantees.
AI is quite a no-go for higher level stuff. But
Of course, the world is changing quite quickly, and I understand that
just
like
saying that,
technology is a
like,
thing.
using past data doesn't always
Right.
yield good results.
So the only thing I can I mean, I could just look. So I could tell you what you want to hear, which is that, oh yeah, sure, you could definitely try to do it, but like, there's just no evidence that that's the case. There's no
well,
evidence that this is going to be a successful attempt.
If we were to assume that you could get all the course online, and the only difference was the lack of like a physical community, would you say that it would be worth trying to do? Is my point, I guess.
I suspect not.
So if we
and
presuppose,
this actually has
I
been
can watch all
studied.
the lectures.
So this has been studied. When people who take online courses just tend to have lower degrees of understanding than people who take in-person courses. And of course, that's a tendency. That's a statistical tendency. But it's like there is a reason why having access to the people who know the field is handy.
No, I'm not disagreeing at all. I'm just wondering like how it sums up to, I don't know, working a bit harder at home. Because I've not really got any. There's no real limitation on how much I'm willing to do. You know, like if it was a question of reading lots of books, I'd be happy to do that. And I'm just wondering if there would be a way to avoid the fee.
What is so? I mean, okay, so what you could do, and what would almost certainly be fine, is you could just go to your local, you could like email professors at your local university and just ask if you can sit on one of their courses. And you could still do the homework, and if
I was gonna go to uni, I'm trying to get into Oxford, so I think I've got my predicted grades and stuff. Like,
are you not allowed to? Like, you could just go sit on one of their lectures, right?
You can go sit in the lectures.
Yeah, I don't see why not. Who's going to stop you? You just walk into the building.
I kind of assumed that you like pay to go. I thought it was like a rare commodity to go to the lectures.
Well, okay, so it might be at Oxford that they're like very strict about it, but like at most universities in the United States,
everyone would go to Oxford to see the lectures.
No, the reason why you go to Oxford, the reason why you pay to go to Oxford is because when you graduate, you have a degree from Oxford. But if you just want to learn this stuff. Yeah, well, I mean, yeah, it shows that you proved something. Like maybe it's not ethical, but like at least in the United States, if you email a professor and say, hey, like I can't afford to take your class, but like I want to learn it, can I come sit in on the lecture? I can't imagine a single professor would say no.
Wait, sorry, what does uni do then? Why would you pay?
Because they certify you. They certify that you've accomplished XYZ things and has come to, they've.
Is that seriously it?
Yeah, of course. Of course. It's a certification. That's what a degree is. A degree is a certification. It's a degree that it's proof that you have proven something, or that you have accomplished something.
But then does that mean that like the whole I go to university because I love the subject thing is like out the window? Well,
look, I mean,
that's quite. I don't know.
Both things can be true.
To me.
Both things can be true, right? But the reason, so there is something to be said that like, likely, if you're not enrolled in a course, you will not be taking the exams. Your exams will not be graded, so you won't get feedback in that regard. There are some things that like your homework assignments will probably not be graded because they're not going to spend extra time, and so you're not going to get that kind of feedback. But like, I can't imagine there'd be maybe at some snooty place like Oxford, maybe they'd be like, no, you may not sit in my class if you're not paying the fee. But like, at least look, like lecturers at these places are scientists and they're teachers and they want to teach people things. And if you say, look, I can't afford it, but I'd love to sit on your lecture, well, I'm sure that they'd let you do that. I don't know why they wouldn't. Now the you probably shouldn't tell the administration. You probably shouldn't tell the administration of the university that you're doing that. Then you'd probably get in trouble.
Yeah.
But
yeah, I guess because then it would lose its. That's quite eye-opening for me, actually. Wow, I didn't realize that was how it worked.
I mean, look, I don't know how it is at Oxford. I know that at Cambridge there are certain places that students are not allowed to go, and you have to like show ID to get in. Maybe that's the same. The same is true at Oxford. But like, I don't know where you are, but at like these kind of more urban universities, like probably King's College or at King's College or no, sorry, what's the large university in London? Is it King's? Is
UCL maybe?
Yeah. You like if these buildings don't have guards, you can just walk in.
Yeah, that is quite cool. See, okay, if I were to be able to get a job through my family, does that just mean I could unironically just learn whatever I want?
Well, yeah, but the thing is, and by the way, the thing that makes it hard to learn physics on your own. By the way, there's some serious echo.
Yeah, I've been muting. Sorry.
Okay, no, you're good. The reason why it's hard to learn physics on your own, or to learn really anything on your own, any challenging subject, is because the reality is that if you're not a full-time student, then you're probably working for a living. And that means that you're spending 8+ hours a day doing something to put food on the table. And then you have to have the mental, the mental fortitude to then go and study for another 5 to 8 hours a day. And it's just not, it's not super feasible for a lot of people.
I've got a medication for that, thankfully. So it's kind of,
okay.
I've been cheating a little bit. I've been experimenting by doing, in America you have like Calc 1, 2, 3, right?
Mm-hmm.
I've been doing the Calc 2 course because it's like a bit after A-level maths. And because I wanted to see like how something like that would work. And it is possible. It's just very you have burnout. Like I have days when I can't do anything and days when I can do 5 or 6 hours. So I wouldn't say it's like a physical limit. It's more quite difficult.
Well, look, you sound young. The thing is as you get older, you have less energy to do these things. You know, you spend 9 hours working on something, and you're like, you get home, and you're just like, I just want to turn off my brain because my brain's been on all day. And maybe that's an age thing. But look, Sam, there are a lot of people who are in the guest box waiting to ask questions, so I'm going to let you go. But
Yeah,
good luck.
I'm sorry. I'll wrap it up.
No,
Thank you.
you're good. You're good. Good luck, okay? Take care.
Yeah, thank you so much, man.
We have a super chat from Fernando Busco with the 5. What's an? I don't know. I feel like I should know this. Brazilian reals. 5 Brazilian reals. Hi, if I am at the speed of light and flash some light ahead, why that light is light speed faster than me, but not for the others at normal speed? Well, you can't be at the speed of light, but you can be near the speed of light. And this is because of relativity. It's just the reality that because of the way your clocks change and because of the way your rulers change, you will observe light going at the same speed as everybody else will observe light going at. And this has been experimentally detected. It might not be intuitive, but it's real. Let me answer some more questions, then I'll bring up our next guest. Yeah, the thing is self-teaching, very few people can do it. Very few people have the willpower to do it properly. Just making sure I don't miss anything. I used to sit in on other lectures on my lunch break when I was at university, was never asked to leave. Yeah, you can just do that, especially if they're big lectures. Now, the more advanced lectures, you might get noticed, but just email the professor beforehand and be like, hey, I'm not enrolled. You don't have to grade my stuff, but can I sit in on the lecture? I want to learn the topic. And they'll probably say yes. I don't know why they wouldn't. Okay, I think that's all of them. Let's bring up somebody from Discord. Let's bring up Akshay. Akshay, you're on. You gotta unmute yourself, though.
Audible?
Yeah, you're good. I can hear you.
A few years ago, I saw a video by Veritasium,
Mm-hmm.
and he was like, just a minute, I'm able to hear like an echo.
Oh yeah, turn off the stream.
Okay, so like he made a video about electric fields and like information in the electric field travels at light speed even though the electrons do not. So
Yep.
why don't electrons in a processor like how does information not travel at that speed?
Well, so okay. The electric field in a vacuum travels at light speed, but so if you have like a wire and outside of the wire is vacuum, then that information will travel at light speed. But if you have a wire in water, then the electric field outside of the wire will travel at whatever will travel at whatever speed it can travel in that medium. And so there is that limitation because the electric fields are embedded in plastic and metal and all these things in the the conductor in the processor. But more, it's about the physical amount of time it takes for electrons to cross barriers, because in order to accumulate charges in various places, those electrons have to physically get to the places. And so if we're talking about like accumulating charge on a capacitor, those charges have to actually get there, and that's going to take time. There's also things like in transistors, there's a turn on time, which is an amount of time these kinds of things have inertia. So there's an amount of time it'll take for transistors to respond to an electric field. Even if the electric field is there, they won't respond instantaneously. So there's going to be delays all over the place. And finally, by the way, the reason why you don't want to make larger and larger processors so you can fit in more transistors is because there is a light speed transmission delay, right? There is a delay time that is affected by the amount of time it takes for a signal to get from here to here. And on the order of, processor speeds that we're working with, where we're talking about gigahertz processors, if you have a processor that's say 30 centimeters across, it's going to take a nanometer or a nanosecond for a signal to get from one end to the other at light speed. And that means that you wouldn't be able to run it really much faster than say 1 gigahertz.
Thank you.
Of course. Anything else?
No.
All right. Well, take care. Thanks for being here. Let's bring up Jomar from TikTok, and then we'll bring up another guest from Discord. Jomar,
Hi.
how's it going?
Hi, how are you?
I'm doing all right. Jomar, what questions you got for me?
I have a question about the Schrödinger cat's thought experiment.
Sure.
Okay. Like, let me first of all, let me say why I wanna ask about it and everything. Okay.
Sure.
So, from how I understand, like the actual thing that was brought up by Schrödinger, it was to explain like wave-particle duality, and not like a whole physical body actually just creating two universes, right? Or
No, not really. Schrödinger brought up this thought experiment as a way of showing how crazy it was, like how crazy this idea of things being in a superposition were.
yeah,
And
that's exactly like what I was.
it wasn't about wave particle duality. It was about superposition.
Okay. So it's not like the whole physical. My point is that it's not the whole physical body of like the cat making two universes, right?
Well, the idea is, at least at the time, Schrödinger wasn't thinking of two universes. He was just thinking that somehow the cat would be in a superposition of dead and alive.
Yeah, that's like the whole thought of the whole point of it. So
Yeah, and he thought that that was absurd, so there must be something wrong with the interpretation that was happening. That was the reason why he brought that up.
yeah, and like I wanted to ask about that because like I see a lot of people just going off from like the Schrödinger cat experiment with like pseudoscientific narratives and stuff, right? And it's really harmful, right? I can't
Yeah,
speak
I agree.
about the harm, but like I've seen the harm. It's really harmful.
Sure.
So yeah, I just want to ask about that because like I've been going on like comments and stuff, and I don't know if I was doing things right, but the one thing I always say is that it's not a thought experiment, it's an analogy, right?
I mean, it is a thought experiment, right? Thought experiments can be analogies, but it is a thought experiment. It's a thought experiment is like a kind of experiment that you conceptualize and you work out what its consequences would be given certain kinds of assumptions, and you do that conceptually rather than, or perhaps even mathematically. Thought experiments can be rigorous, but you just don't conduct the experiment physically. Nobody ever actually put a cat in a box.
Yeah, I thought experiments were like a proof of concept, you know?
It doesn't. Well, so in this case, it's a disproof of concept, if you will, namely the conclusion of this concept of superposition being a thing that all objects can have. If you take that seriously, then you come to the absurd conclusion that cats can be in a superposition of dead and alive, and that's absurd. Therefore, one of the initial assumptions must be false.
I mean, something like I always find funny is that technically it can be true, right? Because what are atoms made of?
Schrödinger wasn't ready for that.
Yeah, like the thing I always do is that I study psychology, right? So I'm really deep into like how the brain works and stuff, and I'm really deep into physics and all science really. So the thing I always like to like think about is that technically the cat can be brain dead, right? If it can be brain dead and like alive, if like every single quark or I forgot their names, tau, electron, and muons, and like
Leptons.
the leptons, yeah. If all the quarks and leptons were like in a certain position, right? The cat can be both dead or alive.
Well, no, that's the claim of Schrödinger is that can't happen. That's absurd.
yeah, but like I mean, it's just crazy to think about. Given like enough chances, right? It can technically happen. Technically, not actually. It can't happen because like.
Well, so the idea is that if that's true, then you've come to that conclusion based off of some set of assumptions, and therefore one of those assumptions must be false because the conclusion you're coming to is absurd. So now we have a perhaps better or more modern understanding where we think maybe that is the case, but when that happens, you get branching into separate universes, and so this is where the many worlds interpretation comes in. In the case of the Copenhagen interpretation, you can get we understand now that you don't even get a superposition of cat being dead or alive because of something called decoherence. And so you get wave function collapse long before you would have a superposition of the cat being dead or alive. So we have resolutions to this now that kind of dismantle or kind of refute Schrodinger's incredulity. But the point that Schrodinger brought up is that this is absurd. There must be something wrong in our assumptions.
Oh, I didn't know about decoherence. I'll go look into that.
Yeah, decoherence is a nice solution, and I think it came about in the 70s or 80s is when the idea came up.
And I want to ask you about like one last thing before I go.
Sure.
How did like Schrodinger go from superpositioning, right, into different universes being like made?
That wasn't Schrodinger. That was what's his name? That was Hugh Everett.
Hugh Everett.
Yeah, so which was like decades later.
But like, how did this theory go from like superpositioning into different universes being created?
Well, they're not different universes like in like the Avengers sense. They're like
no, I mean
it's just you have one quantum system, and that quantum system fully describes reality. And that quantum system can be in a superposition. So if you have two different states that are superposed to form this one quantum reality, then you could call those two things different universes because they can't talk to each other. They both fully describe a consistent reality, and they're just coexisting.
Oh, okay. Like in my head, the universe is like something that has to be bigger than the quantum scale.
No, yeah. So if you take the Everett interpretation seriously, no, everything is like the quantum scale. There is no limit to the quantum scale. It's just that, yeah, indeed, everything is fundamentally quantum, and so you can describe the entire universe via a quantum wave function. That's the idea, anyway.
Oh, okay. Anyways, thank you. I don't want to take up more of your time, but
of course.
Thank you.
Of course. Thanks for being here.
Have a nice.
Oh, I cut him off a little bit early, but thank you so much. From Nathan Irvine with the $5, Pavlov's dog's cost was so shiny because of the conditioning. Pavlov's dog's coat was so shiny because of the conditioning. That's good. That's funny. If we leave out the typos, then it becomes funny. All right, let me make sure I didn't miss any chat questions. All right, let's bring up a guest from Discord then. Breasticles, what a name. Breasticles, how's it going?
Pretty good, you?
I'm doing all right. What questions you got for me?
So it's not necessarily something like directly about physics, but my question is, right, I'm a math student, and some of the topics that I look into and I read into, oftentimes I find I have difficulties getting like supplementary material when I read on it. For example, I've been reading a book called The Analysis of Linear Partial Differential Operators by Lars Hormander. And as I like read into it, or I don't know if you've ever seen like an analysis book for like
I've taken real analysis, don't worry.
Yeah, those books are really dense in material, and so when you try to find like supplementary material for it, it can be very helpful. But as I look into like some of these or look up for like supplementary topics, a lot of the time I find very like base level explanations that aren't particularly helpful for what I'm looking into. Or like another example is, I had to write a paper and I was talking about how the Laplace equation can be used for fluid dynamics, and how you could look at like a circle and then apply a conformal mapping, and then look at the fluid dynamics around the Joukowsky airfoil. But like as I would look into those things, I'd find like what the mapping would be, but I really wouldn't find any explanation as to how to do it, what's the theory behind these type of things. So I was wondering if you have any recommendation as to like a website or a source where I could find, videos or um, papers or books that would provide that supplementary material beyond just kind of a surface level explanation of what I'm looking at.
Yeah, so the unfortunate reality is that as you get into more advanced fields, or more advanced, kind of more niche subjects, you're going to find fewer and fewer of these kinds of supplemental materials, just because fewer people are using them, right? So there's less demand. So probably your best resource would be anything else that your instructor provides. You could go to their office hours and ask if they have any additional notes, for whatever topic. They might actually know some additional books that they would like, or that they like, and that that they're just not using. But the reality is that these things are few and far between, generally speaking. And in fact, in my view, this is arguably one of the best use cases of LLMs. LLMs are very, very good at finding things that are otherwise hard to find. Like, very, very good at finding some niche conversation that happened in a forum 25 years ago, right? That's like kind of like dead on the internet and would be on page 11 of Google. LLMs are very, very good at finding those. So if you use things like ChatGPT or Claude or Gemini or whatever, if you use these things, I don't want to say discreetly is not the right word. If you use these things in a restrained way, be like, hey, I'm trying to understand how this works. Can you give me a hint? That's probably a good use case for what LLMs are actually good at. Because especially, and by the way, I should say, you have to be very, very careful. If you don't have the free models tend to hallucinate a lot more than the paid models. So you have to be very, very careful with what they say. I have a paid model because I use it for literature reviews all the time, so it's very handy to have. But at least at the level of undergrad and early grad school, these things are sufficiently well understood that you should be able to use them as a good resource for like a hint on this thing, or the first step in an explanation for this thing. I think that if nothing else, if you have no other place to turn, that's at least a place that you can go. Just be restrained when you use it. You don't want to become too dependent.
Yeah, I see. Well, I think that was it. That was
okay.
kind of my only question. Was just
all right. Well, good luck. I mean, I wish that there was a better option. I know that it's very easy to become dependent on these things, so it's good to avoid them.
Yeah.
But that is especially for the more advanced topics, like third, fourth year of undergrad or early grad school. Like, it is probably going to be your best resource for these things, because they're so hard to find otherwise.
Yeah.
All right, but I'm gonna let you go. But thank you for being here,
Awesome.
Breasticles.
Yep. Yeah.
Take care.
Yeah, have a good one.
Yeah, that is another point that I should have mentioned, and I don't know if he's still listening. But if you're still listening, Breasticles, which is a great name, it is important that, especially if this is something that you don't know a lot about, ask for the sources. If you're asking for like arguments, or if you're asking for explanations, those arguments or explanations, like arguments, you can often check yourself, because you can just check to make sure that there's no holes in them. But definitely ask for sources for, like, if you're looking for a hint, make sure it'll give you a source, and then make sure that the source is real. You don't have to click on the source, because the source might just have the solution, and you don't want that. But at least make sure the source is real. All right. I don't see any questions. Oh, yeah, from Jaybird. Do you believe it's possible for physics to go beyond our understanding of the quantum realm and go infinitely smaller and smaller? Well, as you get smaller and smaller, it'll still be quantum and quantum, more and more quantum. I don't know if you can go infinitely smaller. We don't know that. It's not clear that our universe has a fundamentally discrete structure of space, in which case there'd be a limit, or maybe there isn't a discrete structure of space, in which case you can go infinitely smaller and smaller. But it might just be the case that there's just no structure below a certain size. You don't have to apologize, Jaybird. Don't apologize for asking a question. All right, let's bring up Valley Wings on TikTok. Valley Wings, how's it going?
Very well. How are you?
I'm doing all right. Valley Wings, what questions you got for me?
Well, string theory. I recognize that it's not acceptable as a grand unifying theory because most of the predictions are untestable. But I'm wondering about the dimensions. Like, are there 11 dimensions in string theory? And do you have any kind of a mentalization of how you can somehow begin to picture? Like, they say that the dimensions like curl into themselves, like they curl somehow. I don't.
Yeah, so
Can you make some more sense of that?
So first, in standard string theory, there are either 10 or 26 dimensions. Now, there are 5 different kinds of string theories, 4 of which are going to have 10 dimensions, 1 of which will have 26. But there was this idea that was, maybe, I guess, started in the 90s, and people still take it seriously, formulated by Ed Witten and others, that you can kind of unify these 5 different theories if you instead think of something that's 11-dimensional. And this is called M theory. M theory is generally 11-dimensional rather than 10-dimensional. And it kind of has all of the aspects of string theory behind it, but it's has a little bit more structure. We don't have to worry about what M theory is, though. So the idea behind these extra dimensions, and we can just take the 10, for example, is you have your normal 3 dimensions of space, 1 dimension of time, and then you have 6 more dimensions. Those 6 more dimensions are exactly as you say, they're curled up. And the right way to think about what it means to be curled up, what it means for a dimension to be curled up, is imagine like a like a hose, right? Like a water hose that you have in your front yard or whatever. So if you're a mile away from that hose, it just looks like a line. It just looks like it doesn't have any width at all. It just looks like a line, which is 1-dimensional, right? A line is a 1-dimensional thing. A square or like a circle or like a disc would be 2-dimensional, etc. But as you zoom in, as you get closer and closer, you see that actually it's not just 1-dimensional. There's actually a second dimension that wraps around. And the reason you didn't see it is because it closes in on itself in a very small way. It's not just like a 2-dimensional extended out in all directions forever, like our normal spatial dimensions are. This one wraps in on itself. So now you have a 2-dimensional thing, but only one of those dimensions is big, and you can see it when you're zoomed out. The other one you have to zoom in a lot to see it, and it closes in on itself because it's small. So that's the idea behind the extra dimensions of string theory. These are called compactified dimensions. They are finite in size, like the circumference of a hose is finite in size. It's only like maybe it's an inch around or something like that. And in the case of these compactified dimensions, they would be extraordinarily small. They would be at 10 to the minus 35 meters or something like this in their size. And so you would have to zoom in more and more in order to detect that they even exist. But that doesn't mean that they don't exist. We just wouldn't be able to interact with them unless you're sufficiently small. And to see what I mean by that, if you were like an ant on the hose, you can walk around the hose, and like that's like a whole journey for you, walking like around the hose. But if you're like a person, you can't really walk around the hose, you're too big. And so fundamental particles, or strings in this case, which are very, very tiny, could wrap around those extra dimensions. But us normal sized people, we're too big. We can't really travel along the dimensions because we're just too big. The scale separation is too large. So that's the rough idea. Does that help at all?
That's awesome.
Is that a yes?
Yeah. Well,
okay, great.
Okay, yeah, that makes a lot more sense. Yeah.
Glad I could be helpful. Anything else?
Yeah, I mean, as a kind of a follow-up, I mean,
sure.
Do you think that, consciousness is such, like, regardless of where it comes from or what it is, it's clearly a very multi-dimensional function.
Different kind of dimension.
Well, right. But is it possible that the ability to simultaneously process so much information in such a vivid way in our experience, could that be because we are this 10 or 26 dimensional entity?
No, I don't think so. I mean, neurons, the reality is neurons are enormous compared to anything at the string scale. Neurons are you know, a few micrometers across or something like this. Whereas an atom is a tenth of a nanometer across, and the protons are 10,000 times smaller than that.
Yeah.
And strings are 20 orders of magnitude smaller than that. So like, no, from a neuron's perspective, those dimensions don't even exist.
Right.
If they exist at all. I mean, string theory might just not be true, but, you know, hard to say.
But I suppose it's possible that some of these quantum fluctuations at like the 0 point energy could be related to particles passing in and out of, well, not the particles are too big to be a part of the higher dimensions. Yeah.
Well, fundamental particles
only the strings could pass through.
In the string theory view, the particles are strings.
Yes. Just kind of like iteratively.
They're just vibrating in different
groupings
ways.
Of strings.
Sort of. Well, the fundamental particles are single strings. They're just vibrating in different ways.
Yeah. And I'm sorry. Yeah, I don't want to go on too far, but so in the strings, obviously, it's not like a substance. It's just a word.
Yeah.
It's just really just energy, I suppose, right? I mean,
I wouldn't go that far. I don't know what it is, but I wouldn't call it energy. I would call it just fundamental strings, whatever they are. They're just fundamental. They're just strings. You can't ask of what they are because they are the fundamental. They just happen to be extended objects rather than, you know, point-like. But I'm gonna let you go, Valley Wings, because I do have a bunch of people that are waiting to come up. But thank you for being here.
Well, thank you.
Now there are a few questions that I want to answer. I have to go help. Oh, that's. I'm sorry to hear that, Jaybird. But good luck. Good luck, Jaybird. I did ask earlier about colors for particles. I know they aren't actual colors, but pop sign ever. Okay, so yeah, the whole business about colors is they're just labels. They're labels for the kind of charge, and because the idea is that we needed some sort of label that conveys different kind of distinct kinds of charge, and yet they can combine to give you neutral. And colors are a great analogy for that, because if you combine red, blue, and green, then you get white out, and we generally think of white as like a neutral color, like it's kind of like it doesn't have any one particular color in it, and one particular hue, and so color is a good analogy for it. From Ethan asks, do you think renormalization should still show up in a fundamental unified QFT? If it's a QFT, yeah, I think so. Renormalization is a normal thing. Question from Moogie. What are your thoughts for when ether cosmologists are retconning the ether to be more in line with a field a la QFT with medium-like behaviors and positive electrons and or photons or solitons of this field? My knee-jerk reaction is that you will come up against issues with Pauli exclusion for the electrons and maybe issues with renormalization. What other major issues should I track for that? Well, look, so the thing is QFT is in some sense an ether theory. It's just a relativistic one. So like ether cosmologists reject relativity. You need relativity in order to make QFT, in order to make sense of QFT. But once you have QFT, you could absolutely talk about it sort of like an ether. Like there's not really an issue there. It is it's not really a medium, but like definitely waves propagate in it. And so it's not a physical substance perhaps, but it's like the thing that waves move through. And you could talk about solitons in those fields, etc. Now there are extra features, like you're right, like this business with Pauli exclusion is a real thing that you have to take into account for. But yeah, I mean, like the Pauli exclusion principle is just telling you about the kinds of states that are allowed to exist in the electron field. Charges of what? Electromagnetism again? No, it's a different kind of charge. So these are charges of the strong nuclear force of quantum chromodynamics. So there's electric charge, or there's the charge that is so every force has an associated charge, every quantum fundamental force anyway. There's electric charge, which is the charge associated with electromagnetism. There's something called weak isospin and weak hypercharge. These are the two different charges associated with the weak nuclear force. And then there's three different charges associated with the strong nuclear force. These are red, blue, and green. What would the quantum fields do without time passing? Would waves even exist in that state? If there's no time, then like a wave equation is a kind of time. It's an equation that relates temporal changes to spatial changes. So if there's no time, then you don't really have a wave equation. All right, let me bring up Doubting Thomas, because I believe Doubting Thomas was next.
Hello?
Doubting Thomas, how's it going?
Good. How are you?
I'm doing all right. What questions you got for me?
Yes. We had debated previously.
Okay.
Sorry, I gotta turn off the
Yeah.
other one. So we had debated previously on the beginning of the universe, but I mean, I'm a quantum optical physics or whatnot. I wanted to get your perspective from someone on gravity and cosmology, if you don't mind.
Sure.
So do you or others in your field treat vacuum fluctuations or fluctuations of the vacuum field as a convenient mathematical bookkeeping mechanism or something real ontologically?
I think it really just depends on who you're talking to. So there are okay, so I mean, you're a physicist, so you know what I'm talking about. So you can talk about like expectation values of various operators, and the way that you might talk, like, and those expectation values can be non-zero, right? And the way you might talk about those expectation values in like the prose in a paper, or like when you're giving a talk or something, is you might explain it in terms of these quantum fluctuations, but really the expectation values can just be non-zero, even in the view that there are no such things as quantum fluctuations. They're just a mathematical tool, that this is just like a way of describing certain kind of, you know, perhaps QFT features that you're seeing, or whatever it is you're talking about. I think that generally kind of the conceptual view that a lot of people have is they actually do think about quantum fluctuations. I try not to, because I hold the view that these are not real things, but it's a very easy kind of mnemonic to use, if that makes sense.
Yeah, that makes a lot of sense. Thanks. So there's twofold reasons why I wanted to ask that. So
Sure.
on your end, probably the first interesting part is that it says something a lot about the how much of a crisis it is, so to speak, regarding the cosmological vacuum field problem. I
Sure.
just mentioned that to start off, because the one is our math is just simply just not particularly refined enough. And then the second one is we don't fundamentally understand something real about physics. I don't know. Maybe you could say it's the same. Both are our problem, but it seems like the weight of one is bigger than the other.
So I don't think that you don't have to. You can be okay saying that there are no such things as like virtual particles popping in and out of existence, or that, like, you know, a ground state is genuinely static, and so there's nothing that actually happens in a ground state. And that ground state can still have a non-zero vacuum expectation value, or it could still have a non-zero vacuum energy density.
Yes.
And so, like, it seems like that there's not really a philosophical problem there, in my view. I don't think that you don't need to have this view of, you know, vacuum fluctuations in order to say that, oh yeah, the ground state energy of your, you know, whatever your preferred QFT is this value. Now, there are problems with the mathematics. Surely, I think that the assumption that the ground state energy, and of course this is regulated, right? You regulate typically at the Planck scale or something. The ground state energy of some QFT being roughly equal to the Planck energy, I think that that's probably just a mistaken assumption, that has anything to do with the, you know, the energy density of empty space. Because of course in QFT all energies are relative, right? They're just relative to some fixed 0 point, whereas in relativity, the energies are absolute, right? The energies, the stress, the momenta, the stresses, and so on. So these are absolute. So to say that because we compute some relative energy relative to some, you know, arbitrary fixed point, and that gives us a Planckian energy density, and therefore we should assume that there's a Planckian energy density in GR, that seems entirely mistaken to me. And so you know, my contention is just that, you know, maybe there is a cosmological constant problem, but it's not that one.
Yeah, fair enough. No, that's good. Yeah, thank you. I'm going to chew on that a bit.
Fair enough.
The second reason why I was saying that this is interesting, this is on my end, and this is maybe a bit radical, you might say, but I think I can make the case overall that, and we don't need to get too deep into this, but I think you can make the case that if you are pro, it's just simply mathematical, and we don't even need to treat, and it's not in fact real in some sense. It is pure mathematical bookkeeping. If you hold that like non-ontological view, I think you might be able to make the case that you can say the same thing about real photons as well, because the on-shell versus off-shell, from my perspective, is really just a Heisenberg uncertainty limit in a sense, if you see what I'm getting at.
I don't know if I would say it's a Heisenberg. Well, okay, yeah, in a sense. But I thought that you were going to go a different way, which is a separate problem, which is, namely, we call something off-shell if you have a Feynman diagram that has external legs.
Yes.
The external legs are off-shell. But at the end of the day, when a photon hits your eyeball, there is no external legs in that interaction. It's just a really long range. You could just say it's a really long range Feynman diagram, and then there's an interaction
you
between.
You can look at it exactly the same way as well. Those two questions, Heisenberg versus what you're describing, are related, but you're absolutely
I
right.
think so. And so I think that that's a problem. I think that and I think that this is probably getting at something deeper. I don't know what the solution is, but I think that really what we want to say when we're talking about something on-shell versus off-shell is that in some sense, the on-shell thing, for most of its existence, whatever that is, if there are off-shell things, the on-shell we call something on-shell when it behaves like it obeys like a free wave, it propagates freely, if you will, for like a long time. And that's what we call an on-shell thing. And if it doesn't propagate freely, if it propagates via some non-free if it has some non-free propagator for most of its existence, then we would just call that off-shell. And so I think that you're right. I think that there is something deeper there. I just don't know what the solution is.
Yeah, fair enough, and that's why that's why I'm taking that extreme view in a sense that I'm fine if we want to just limit it to saying it's a mathematical artifact. Then I think we need to commit further. We need to take that to a larger commitment overall when it comes to real photons, or at least be more at least at the very least when we talk about light in terms of waves. At the very least, we talk about the mathematical substrate that we're talking about. At least some aspect of it. Then we need to there might be a sort of a thinning or differentiation that needs to be done between what's mathematical and what's not mathematical.
So I think that, and to be clear, there obviously are actual quantum fluctuations in a non-vacuum state. Like obviously, of course, like any sort of electromagnetic wave, whether it's a single photon state or not, there are genuine fluctuations there because the thing is propagating.
Because you can always calculate the standard deviation of any particular field. Yeah.
Right. And those can change in time, right? Yep. When you have a non-vacuum state, those expectation values can change in time, right? And so we could call those, and those fluctuations absolutely exist. As far as I'm concerned, if something has there is at least something real about expectation values because those are explicitly measurable. Now, when I say that the vacuum doesn't have fluctuations, that's because the vacuum is defined to be time invariant, so it has to be static. And when I talk about virtual particles, I say that those are not real for a slightly different reason, which is namely that the way that I understand a virtual particle state is merely essentially a Fourier decomposition of some non-particle some non-particle state of whatever the underlying field is. So you could imagine that you have a static Coulomb field near an electron or near some charged particle. Say it's not an electron, say it's just a large macroscopic charged whatever. You'll have a static Coulomb field, and you could decompose that static Coulomb field into an infinite sum, almost like a Fourier decomposition of photon states. But that's not a real thing. The real thing is that the electric field is in this Coulomb configuration, and so the virtual particle.
You're getting into photon dressing. You're getting into photon dressing in a sense, yes. And of course, you then have a bare photon charge versus observed photon charge, but
electron charge. But
electron charge. Yeah.
So the whole business of quantum fluctuations versus virtual particles, and in a sense off-shell particles too, I think that these are kind of separate issues, but they're both issues.
Yes. All right. Well, yeah, it's interesting. So you're coming from it's very interesting because you're coming from a different perspective than I am to some degree, but I think we see the
writing on the wall, if you will.
Yeah. Yes. Absolutely.
Yeah, sure.
Absolutely. Okay, that's all I wanted to just. One last thing, if you don't mind. I had realized from our recent debate where I was taking. It was a creation debate about the beginning of the universe. Mm-hmm. I was trying to mull over what you were your position a bit more, and I got the impression. Please correct me if I'm wrong, but it seems like where you your flavor of liking of models, if there is no strict beginning, or if it's only not even a fuzzy beginning, it sounds like, rather than, more particular than um uh a eternal universe, probably it sounds like you have some proclivity. We can not say that you believe in it, but a proclivity towards something like a cyclical universe, or
Yeah,
something that's very
absolutely,
similar
I
to
do.
that.
So
Yeah.
so like I mean, I think that there would be a degree of elegance in that, and like, in some sense, if you ask physicists, I'm a mathematician, right? So, mathematicians are driven a lot by elegance and by simplicity and things like that. So, yeah, it's definitely true that things that interest me is trying to build models that in some degree get you some sort of cyclic kind of phenomenology, because I don't think that's been investigated particularly well, just because the standard model of cosmology has been really successful, so there hasn't really been a reason to. But B, like, there is some it is entirely plausible that our universe is spatially compact. For those listening, what that means is that our universe has finite size, even if it doesn't have a boundary. Think of like the surface of the Earth has a finite size, like there's a finite surface area of the Earth, but there's no edge. You could just keep going in one direction forever, and it'll just loop back in on itself eventually. So there is good reason to think that our universe spatially is compact. There's nice reasons from quantum gravity that would lend itself to this kind of interpretation, and it's at least consistent with the data to have that view. And so I'm like, look, if space and time are supposed to be so closely linked, wouldn't it be nice if time was also compact, that it looped on itself as well? And so like it's a pure drive from like elegance and simplicity, and you're right, I do have a proclivity for it, but as far as to like what I'm committed to, I try to stay really, really separate from this like inclination, if you will.
Yeah, no, absolutely. Yeah. And I'll lastly just mention, of course, you don't need to have a cyclic cosmology. You could still have some, although it would be very different than how we perceive it, but it can have some sort of beginning still, and it solves some sort of bootstrapping problems, or forcing a closure that creates its own problems. But yes.
Yeah, I mean, there definitely are, like, anytime that you have any sort of cyclic time, it sounds like, unless you're very careful, it sounds like you run into like bootstrapping problems. Exactly. I'm not convinced that that's actually a problem, but it's very hard to think about.
Yeah.
So,
correct.
All right, I'm gonna let you go and bring up another guest, but thanks for being here, bud.
Take care.
All right, we do have some super chats and some other questions to get to, and then I'll bring up another guest from TikTok. From Nathan Irvine with the $5. My physics teacher said I have potential, then pushed me down the stairs. That's a funny joke, and also mean if true. I don't think it's actually true, but it is mean if true. And from Mike DeKnight with the $10, I may be overthinking it, but what exactly is mass? Why is mass and weight, at least on Earth, sometimes used interchangeably? If mass is weight divided by g, and m is density times volume, and m is F equals ma, how are these equations unified? So mass and weight are used interchangeably on Earth because they are directly proportional to one another, exactly as you write. Mass is equal to the weight divided by the gravitational acceleration. And so because they're proportional, you can talk about them in the exact same way, and you can even use the same units. So when somebody says, XYZ thing weighs 10 kilograms, what they really mean is that it has a mass of 10 kilograms, and its weight can be found by multiplying its mass by the gravitational acceleration downward. It's just a shorthand, basically. Mass is density times volume, that's true. And mass is also the force divided by the acceleration, also true. Those equations are, there's not really like a way to unify those equations. They're just all true, and they're all talking about related things. So, like, there's like you could say that weight, at least for if the only force acting on something is the gravitational force, then the first and third equation, mass equals weight divided by gravity, and mass equals force divided by weight, or divided by acceleration, all this is saying is that the weight is the force and the gravitational acceleration is the acceleration. And then of course you can write things in terms of density and volume, but that's not always going to be super helpful, so you just might not always do that. We have some questions, I think, from the regular chat as well. No, we don't. Okay, so I'll bring up another guest from TikTok. I'll bring up Starro Crazy. Start with Crazy. How's it
Hello.
going?
I'm well, thank you. How are you?
I'm doing all right. What questions you got for me?
So, I'm currently doing a maths undergrad,
Okay.
and I'm on a research project in the Czech Republic at the moment.
Oh, where are you?
Well,
if you don't mind telling me.
I'm in Ostrava, right in the east.
Oh, okay. Yeah, sure. I've only passed through Ostrava, but when I passed through, it was lovely.
Yeah, it is nice here. Although I say research project in maybe the biggest air quotes possible.
Sure.
But the title of my project is the cosmological constant from Einstein's blunder to the accelerating universe.
Mm-hmm.
And so my first question is, what do we mean when we say the universe is geometrically flat or hyperbolic, or like, I know they all relate to the sort of density of the universe, but when we talk about the universe being flat, obviously the observable universe is a sphere. So it just kind of confuses me a little bit.
So the observable universe, and there's what year are you in your undergrad, if you don't mind me asking?
I'm in my second year, going into third. So
Have you taken topology yet?
No, that will be next year.
Okay, so technically the observable universe is a ball, not a sphere. So when we talk topologically, we're talking about when we say a sphere, we really mean like what you would call like the surface of the Earth would be like a two-dimensional sphere.
Yeah, okay, yeah.
Whereas the Earth is a three-dimensional ball because it's like, it's just the language that we use. But so the observable universe is a three-dimensional ball. Its boundary would be a two-dimensional sphere. But when we talk about the curvature of space, we're really not talking about the observable universe. We're talking about the intrinsic curvature of a given moment of time. So a given moment of time corresponds to a set of space-time points that are like space, if you will, right? Imagine that like space-time is like a loaf of bread. Each slice of bread is like a moment of time, so it's like a chunk of space. So what we're really talking about is the intrinsic curvature of like each slice of space. And so what we're really talking about there is if you took all of the matter away, if you took all of the energy away, would there still be something left over? Would there still be some sort of intrinsic curvature built into it? Or would there be nothing, in which case it would be flat? So if there is some sort of positive intrinsic curvature, what we mean, then that would mean that it's, it has positive curvature, and so it would be spherical, rough is the language that you would use. And then if it had negative intrinsic curvature, it would be hyperbolic. If it's flat, or if it has zero intrinsic curvature, it would be flat. And so this is just telling us, it does tell you something about the topology, about like whether the universe is finite or infinite or whatever. In particular, if the universe does have positive intrinsic curvature spatially, then the universe is finite. That's something that you can prove. But really, the point is that this informs on how the universe evolves over time. Positive intrinsic curvature tends to want to make the universe kind of collapse in on itself. Negative
it's all related to like it's an eventual fate, right?
Yeah. Now, of course, you can have a universe that expands forever that is positively curved, as long as you have like enough dark energy or something like that. And so you can actually figure out how curved the universe is, like what the intrinsic curvature of space is, by looking at other quantities. And essentially, there is because there's a rate of expansion. There's something called the Hubble constant. The Hubble constant squared, there's an equation that tells you the Hubble constant squared has to be equal to a certain sum. And that sum involves things like the density of matter today, the density of radiation today, the density of dark energy today. And it also involves the intrinsic or extrinsic, or the intrinsic curvature of space. And so if you can measure the densities of these of these various kinds of energy, like matter or radiation or dark energy, then that will tell you, because we know what the Hubble rate is today, that will tell you what the intrinsic curvature has to be. And so if we call it the critical density, if the sum total of these densities is exactly at the critical density, then that means that the intrinsic curvature has to be 0. And if it's not exactly at this critical density, then that means that the intrinsic curvature has to be either positive or negative, depending on whether it's less than or greater than the critical density. So that's where that comes from. It comes from something called the Friedman equation, if you want to look this up on on your own time.
Okay, right.
Does that help?
I did have another question, but it
Sure,
seems
go
to have
ahead.
slipped my mind.
Oh, sorry.
The I'll drop it in the Discord if I think of it.
Okay, sounds good.
Thank you for your time anyway.
Yeah, of course. Good luck.
Cheers.
All right. Let's see if we have any other questions in the chat. Question related to cyclic universes. Could a heat death state be fundamentally unstable in a way that allows for extreme quantum events like another Big Bang? Maybe. I don't know if that would be quite cyclic though. Cyclic typically implies that it kind of repeats itself. Exactly, that it's in some, but what you seem to be describing is more of the like kind of like a recurring thing that doesn't have to be the same every time. Let's bring up I don't know from Discord. I don't know. You were on.
Hello.
Howdy.
How are you?
I'm doing all right. What you got? What questions you got for me?
So my question is, before Big Bang, what happened?
I don't know.
You don't know?
I don't know.
I mean, is there any research or any paper?
There's lots of research, but we don't have data that says anything one way or the other.
Okay, so okay. My next question: why Earth is rotating?
Sorry, is the Earth rotating?
Yes, why the Earth is rotating?
Oh,
around
why
the
it's
sun?
rotating? Because the stuff that formed Earth had angular momentum. So imagine that you have like two lumps of clay, and they're coming at each other, but they're coming at each other and they're going to stick together when they hit, but they're coming at each other at an off angle. So like they come at each other and then they hit, and so then they'll start rotating this way, right? It's just because of the way that the Earth formed.
So why there are many planets rotating around the sun? Because
Why are there
after
many?
Big Bang, I mean after Big Bang, the planet should go away and scatter away.
Well,
But
the
there
Big
is a
Bang didn't
pattern
create
around
the planets didn't exist in the Big Bang. The planets formed a long time after the Big Bang. The planets formed from basically a cloud of dust that was seeded by earlier stars exploding and the like. So the Big Bang wasn't the dominant, like it was gravity that brought everything together to form, say, the solar system.
So you think that gravity from sun make other planets close together, right?
Gravity is one of the things is a key driver in various planetary dynamics. Yeah.
Okay. My next question is why we are not producing electricity from lightning?
I don't know. It seems hard.
But you are a scientist, right? You can find things like generating electricity from lightning. It would be so much of electricity in Earth.
I mean, I don't know how much electricity it would generate, but it seems hard to be able to predict where lightning's going to strike and to be able to then generate electricity from an extremely energetic pulse.
There are many places where raining occurs oftenly and lightning also occurs.
Okay, well, look, it's just not the kind of science that I do. If somebody else wants to do that, they can. It's just not what I do.
Okay. So, do you think that whatever the Einstein said is true?
Sorry, one more time? Do I think what?
And do you think that whatever things the scientist Albert Einstein said is true?
A lot of things that Albert Einstein said is true, yeah.
But currently, most of the people we think that most of the things said by that Albert Einstein is true. But after few hundred years, people will again say that the findings of Albert Einstein was false. So,
maybe, who knows?
My question is, should we always rely on his equation?
We rely on stuff that has been experimentally verified. So like if there is good reason to believe it, if the evidence is pointing towards something being true, that's what we rely on.
The experiments
The experimental data, yeah. Experimental and observational data is what we rely on. And it seems like Einstein's ideas have been verified spectacularly by these experimental and observational data.
I am not understanding the theory. Einstein said, like, you know, it is like Earth is like placed in a curvature of a net. I didn't understand that. I studied about that a lot, but I didn't get. Can you tell me
There's a lot
simple way? Because
there is no simple description of it. It's a deep mathematical idea, so it depends on how strong your mathematics is.
mathematics is just an imaginary thing, right?
Yeah, but it's the way that we describe complicated ideas, like Einstein's.
So I think that the Earth is not in a pouch, like Einstein said. Earth is like Earth is moving in a different type of thing. Earth is not like in a pouch thing, like Einstein said. I
Earth is
totally
not like a
disagree.
what?
You know, Einstein said that the Earth is in a like a pouch.
It's like a boat? I don't think Einstein said that Earth is a boat.
No, not about boat. Like Earth is in a time.
Look, your connection's not very good, so it's a little bit hard to understand you. So if you try to speak a little bit more slowly or a little bit more clearly, that'd be good.
Okay.
All right, well, I'm gonna let you go. I don't know, but thank you for being here. There are some questions that I want to get to in the live stream. We have to end the live stream soon, so I know that I didn't get to a lot of people who have been waiting. I've tried to, but you know, I can only take so many. Let me answer some questions, then we'll call it a day. What are your main goals in using conformal geometry in physics? I guess, what is the way that using a form of geometry that only uses angles and not distances is used in producing physics results? So, look, I mean, first, I'm interested in conformal geometry for its own sake. Like, it doesn't have to do with physics, and a lot of the physics I do is not using conformal geometry. But some of it does, and it turns out that, like, the conformal geometry really, really well describes the trajectories or the paths that light takes. Because light doesn't travel, the proper distance that light travels is always 0, right? And so you can rescale that by any amount and it's still always 0. So conformal geometry preserves the causal structure of space-time. So you can learn a lot about a space-time just by learning how light rays travel, and that will tell you about like what's in the past of what's in the future of what is causally disconnected from other things. So there's a lot that you can learn just by studying conformal structure. The only extra piece of information that you get that you're missing from conformal structure of space-time is all you're missing is the volume. That's the only thing that you're missing. You don't need any, like, if you can tell me what the volume of space-time is at each individual point, and then you give me the conformal structure, that's enough to completely determine the space-time. So conformal structure is useful. Now, I don't use it in all of the work that I do, all the physics stuff that I do, but it does show up occasionally. Anyway, I am going to end the live stream here because I am all talked out. I feel like I'm probably going to lose my voice, and I have a late night tonight. So thank you guys so much for being here. I will be live again. I have to get up super early tomorrow, and I have a late night tonight. So I don't know when I'll be live tomorrow, but I will try to be live tomorrow for some more Ask a Physicist. In the meantime, make sure to go join the Discord and ask questions there. So thank you guys so much for being here, and I will see you guys hopefully tomorrow.